Unreal Engine is a 3D computer graphics game engine that has been used to create many popular games. In this full course for beginners, Surav will teach you how to use Unreal Engine 5. Surav has 7 years of game development experience and has developed multiple games.
Hi there, game devs. Welcome to my beginner to advanced game development course on Unreal Engine 5. In this course, we'll be taking a deep dive into the engine, and hopefully by the end of this course, you would be able to create a game completely by yourself. Now, before you actually start developing a game in Unreal Engine, some of you guys may have a question on what sort of a system to get for Unreal Engine. Now, the docs is a bit outdated on this page. However, this page, whatever's there, is insufficient in my opinion. I have been working on Unreal Engine for almost 7 years now, and I feel this system isn't going to be handling anything. So 8 gigs of RAM isn't enough, and for the video card I would recommend at least going for something like a 1650 or an RTX 3050 if you were to ask me. I have worked in Unreal for about 4 to 5 years with a 1050 Ti. That totally works. However, your experience isn't going to be that great, and you will have to turn down all the settings as well. And for the CPU, a Ryzen 5 or an Intel i7 would do. 6 cores or higher, preferably 8 or even 12 cores would be better. But make sure if you do get more number of cores, you scale up the other components as well. There are a couple of things. For example, in Visual Studio, when you compile a program, you will actually need more RAM as you scale up the number of cores on your CPU. So that's one thing to note. And if you scroll down, you would see this list over here. Although this system is highly overkill and the GPU is outdated, of course, one noteworthy thing is a solid state drive, which I highly recommend. Do not use a hard drive for your active projects. The experience isn't going to be that great. So with that all being said, let's actually start by talking about the installation process. Now there are two ways in which you can get hands on Unreal Engine. One is through the Epic Games launcher. So just search Epic Games launcher, download the launcher, and once you actually log in and do the regular sign up stuff, you can go ahead and click on Unreal Engine and head into library, and you should be able to add an engine version. Now as of this date, the latest stable build is 5.0.3. However, 5.1 is in preview, and we shall hopefully upgrade to that. It has quite a few exciting features which I would love to show. And the other way is to download the source code. Now you could use Git or something and copy the link and clone it like that, or you could just download the zip file from here. And then there are a bunch of steps to actually install it. We'll be going through this later in the course, and also for more advanced users, those of you who will be working with dedicated servers might need the source build as well. Now if you guys don't have access to this repository, you just have to request the permission. This is a private repository by default, and it's pretty easy to get it. And once you do get access to it, you will be able to view this page. There are quite a few tutorials on YouTube on how to do that, so you guys could check any one of those out. Once you install the Unreal editor through the Epic Games launcher, you'll also need a code editor in order to work with the C++ files. So generally you use Visual Studio for it. Now the documentation goes pretty well on what components you need and stuff. And if you do need any additional components, the installer is going to prompt you, and it's pretty straightforward to be honest. Now you don't require VS 2019, you could use 2022, there is absolutely no issues. I'll be showing you guys how to set the default code editor to be VS 2022 as well a bit later. So that's about it for the code editor. I guess now we can go ahead and create a project, and let's create a game. So I'm in the Epic Games launcher right now, And before we actually launch the engine, I just wanted to talk about the installation options. Try your best, even though it looks large, to have debugging symbols. Those are going to help us out later. Now you can go ahead and click launch. Once the loading is done, you should be inside the Unreal project browser where you can create your projects. Now yours might look a bit different. I haven't selected templates, so I don't see first person, third person and all that. However, our intention here is to learn, so we aren't really going to use those templates. We might look into them a bit later on, but for now we'll be starting with a blank project. And a couple of noteworthy things. Two things actually. The first thing is the project location. I always suggest having an Unreal projects folder in your solid state drive and maybe move them to a secondary drive if you're not working on them. Now for the project defaults, everything is fine except Blueprint and C++. Basically every C++ project will have Blueprint and everything else that you'll need to work with the editor. However, when you select a Blueprint project, there is one additional step if you want to start working with C++ as well. Please note that Blueprint and C++ work complementary with each other, and every project in my opinion should use a combination of the two and shouldn't be purely C++ nor should be purely Blueprint. So let's create a C++ project and let's leave it at desktop, maximum, and we didn't download the starter content so we don't have it, but that's totally fine. We can add it later on. Now for the project name, we can go ahead and name it. Let's call it beginner to advanced course, or I'll just call it beginner course. So let's create that. Once you open your project, a Visual Studio window like this with your project solution open should be open by default. If not, head into the editor, go to tools and click on open Visual Studio 2022. And here's where I'll just show you guys how to change the default code editor. Let's say you have a slower computer, head into editor preferences and over here type in code editor and you should be able to change it to Visual Studio Code or whatever. Let's say you do change it to VS Code. Over here under tools again, you should be able to find refresh Visual Studio Code project. Once you do that, you should be good to go. One thing that you will immediately notice is my editor layout does not look exactly like yours. The reason is I have set mine to the Unreal Engine 4 layout. So the way you do that is by heading into Windows, load layout, and this is the one you will probably have. And you can hit Control space in order to get your content drawer. But I feel like it just adds an additional step in viewing your content, and I honestly prefer the Unreal Engine 4 layout, but it's completely up to you. Everything else should be in the same place. So I'm going to be using the UE4 layout. You can choose to use the default one if you wish. And in case you want to go full screen here in the UE4 layout, just get your viewport into focus. Just in case you're wondering, the middle large portion of the screen is called the viewport. Once you get it into focus, hit F11 on your keyboard to go full screen. Let's start talking about the actual GUI of the Unreal Editor. So the first thing is your menu bar, which contains File, Edit, Window, Tools, Build, Select, and so on. These are just the normal options that you would see in any other computer software. So let's say you wanted to save everything, you would go ahead and click Save All. However, there's a key over here as well on the content browser, which you will be using more often in this editor. And under edit, you also have a couple of important things. Obviously, for undo, redo, and functionality like that, you'll prefer the shortcut keys. So for example, let's say I add in a light over here and I go to edit. You could undo that, but I just prefer using Ctrl Z and Ctrl Y. And The editor preferences, project settings, and plugins are a couple of options which you will use quite a bit. We will be getting into all of those in detail later on. Now, window, as the name suggests, has to do with your actual GUI. So, here, for example, if I wanted to know what game mode I have, and again, we will be getting into all of that. So, I can just go to world settings, which contains the game mode info. So, it says game mode override none. We can set that to be game mode, for example, and stuff like that. It all depends on what you exactly need. You could grab in a second viewport as well in case you needed it, stuff like that. And under tools, the only thing which we'll probably use here is going to be creating a new C++ class, and occasionally we might need to refresh our project file. And nothing else actually. Find in blueprints is something handy. So in case you have written some blueprint code and you want to find it, like in your entire project, then it's a useful thing. And build is for building your lighting and stuff, basically baking your lighting. Select, not really sure who would use that because most of the operations over there can be done by shortcut keys. So that's your menu bar, and under this there's another panel over here where you have another save button, and under this select mode option over here you have quite a few options. Landscape is something which you will use when you're working with larger maps, so you can go ahead and create landscapes. So what I'll do is I'll create a brand new level to showcase those things, and over here in blueprints, this is where you'd access your level blueprint, and I will get to what is that a bit later. This option right here is mostly for cinematics. So let's say you're making a trailer for your game or something. These are the things which you would use. And this is just to play your game. So if I hit play, I can see what the game looks like while you're playing it. One more thing. Let's say you wanted to look at how your game looked while you're playing without actually playing it. You can press G on your keyboard and it's going to go into game mode, which will show you exactly how your game will look when it is being played. And next up, you have this button right here where it allows you to launch the game and stuff. We'll be going into this a bit in detail later on. Now, for those of you guys who have slower computers, you can head into settings over here, engine scalability settings, and you can set yours to low. Now, how do you check your frame rate, you may ask? Because that's a major concern. I feel like you do require about 50 to 60 FPS in order to have a smooth editor experience. So the way you check that is by hitting your tilde key under your escape key, that is, if you guys aren't familiar. Once you do that, your focus should be in this enter console command window at the bottom of your screen. Type in stat FPS. And you might see that it's locked at 120 if you have a fast computer. So what I'll do is I'll type in t.max FPS, and you can just type in a crazy value like 999. So this is my actual uncapped frame rate. Now this introduces us to another window. This is known as the console. Now the console is really useful. Basically almost every setting you see over here and quite a few other settings which we will talk about later can be set using the console. It's quite handy. Let's say you're debugging your game and you don't have an actual button to change your graphic settings. You could use the console and change it as well. There are many other uses for it. For example, in multiplayer you can simulate lag and stuff like that in order to represent an actual multiplayer game. So that's the console. And your output log is your output log. So let's say I've printed something. It's going to stay on your screen for about 2 seconds or how much ever you set the duration. But the output log is always going to have the print. So for example, now we haven't gone into blueprints, but I'll just print something and show you guys. If I just type in print string hello, you see you get hello over here. But it's gone after 2 seconds. However, in the output log, you should be able to still see hello. It should be all the way down. As you see, you get hello. Now don't worry about all these errors. It's really nothing to worry about. So that's about it. And on the left hand side, you have the place actors panel, where you have various options. You'll really not be using this. You'll generally just drag those from the content browser. It just contains the same old things, and the recent tab may be helpful if you're placing the same object over and over again. One thing that you might use this for is for a player start. Player start is basically where your player is gonna spawn. Just press G on your keyboard. If it ever disappears, you're probably in game mode if you don't see it. And if you want to get close to it, like how I did, make sure that is selected and press F on your keyboard. F stands for focus, and it's going to go near it. The camera is going to go near that. Now, once that's done, let's talk about this massive chunk of the screen. This is known as the viewport. This is where you'll actually arrange your level and do stuff. So for example, if you want to place something, you drag that in the viewport and that's going to be added into your level. Now, in order to navigate your viewport, there are quite a few methods which you can use. One is known as the Maya style navigation, where you use Alt and your mouse buttons. And there are many other styles which I won't get into. It's kind of pointless. But there is one style which I personally prefer, and I feel almost everyone is going to prefer that. That is by using your right mouse button and your WASD. This is similar to how you move in video games, except you're holding the right mouse button here. So hold down your right mouse button and you can use your W, A, S and D keys and move your mouse. So this gives you all degrees of freedom. So you can rotate, you can pan around, you can do everything. So this is my favorite way of navigating. Just try it a couple of times. It's just a matter of getting the feel of it. And if I want to speed up the camera, which I will get into later, you can use your scroll wheel along with this and your camera speed is going to change. There are a couple of options again here. Now here, instead of the console command, you could use this as well to show your FPS. And there are quite a few other options which you would generally not use. Screen percentage is basically a resolution scale. You could set that all the way up there. I'd leave mine at 100. And this is to change between perspective and orthographic views. Let's say you're aligning something from the top. You would go to your top orthographic view. Now you might see everything is wireframe. So you can change that here as well. Go to lit. Let's say there are shadows interrupting your work. You could head into unlit. There are many other view modes which you generally use for optimization and things like that. But generally you'd stay in lit, unlit or wireframe itself. Maybe a couple of times you might use one of these other settings, but I've never found myself needing those. So that's there. And scalability is basically the same thing which we saw over here. I can set that to cinematic, for example. In my case, it shouldn't really matter. That's about it. And in these options on the right hand side, this one basically allows you to select objects. So let's say I click on this, I select this. Now let me get closer a bit. Set into perspective. So if I click on this, I can select it. Now when I click on something, now I'll create another point light. When I click on something and I have it selected, if I want to move it, I can press W on the keyboard. Or if I want to rotate it, I can press E on the keyboard. And if I want to scale it, for a light it's kind of useless, but it is going to scale the radius, I believe. So for that I can hit R on my keyboard in order to scale things, or you could use these buttons over here. So this is for move, this is for rotate, and this is for scale. Alright, so once that's said, this button right here changes between local and world space. Now over here, if I just drag in a cube, for example, under shapes you should find cube, and if I change this to local space, now when I rotate this cube, you see the gizmo rotates along with it, and now I can move it along its rotation. But let's say I wanted to rotate it along with the world's XYZ. The way I do that is by heading into world space. So now you see it's aligned to the world's XYZ, that is your actual coordinate axis. But this cube is rotated, as you can see. So if I want to move it along that rotation, I can head into local space. Again, if you're familiar with 3D modeling software, these will sound pretty familiar to you. The next thing is grid snapping. Now, if I were to come close enough, you would see that it's moving in increments. It's not moving smoothly. That's because grid snapping is enabled and snapping distance is set to 10. So I can just click on this button and disable grid snapping, and now you see the object move smoothly. Same goes with rotation. If I disable that, I can smoothly rotate the object. If I enable that, it's going to rotate in increments of 10. Same with the scale as well. Now, this map is pretty huge and it's taking quite a while for me to actually go this far. So the way I can actually move faster is by using this camera speed button. So if I head into 8, as you see, we are moving very fast. One more thing is, if you scroll while using your right click and WASD, basically I'm using that to move. If you use right click and WASD and you scroll at the same time, you can actually adjust your camera speed. So I have my right mouse button held, I have WASD to move, and if I scroll forward, I'm going to move real fast. Now let's say I scroll backwards, I'm going to go slower. So you can adjust your camera speed with your scroll wheel as well. And of course you can adjust it over here. And if you want the camera to be even faster, you can go ahead and set this multiplier thing. And that's about it. Now let's actually start creating something. So the way you would actually go about doing stuff is creating something under your content folder. Now you might have some things over here if you have enabled starter content and stuff, but in our case we don't have anything. So one thing is, whenever you create new levels, it's always advisable to have a maps folder in your content folder where you actually put all your maps. So head into this folder, and in order to actually create a blank level where you can start making your own, right click, click on create basic asset level, or you can head into file new level, anyway is okay, and we can call this one beginner course level. You could call it anything you want. Double click on it to open it up, and I've already saved it. It's asking us to save this map actually, so actually don't save this. Now head into your project settings, and this is where we start talking about some of the things which you might need. The first thing is maps and modes. So in order to decide which level is going to open when you start the editor, this is where you actually set it. So anything associated with your project will be over here. So for example, your input bindings is something which you'll use a lot. So all of those are there in the project settings. So we can change the editor startup map to be beginner course level, and we can set this to be beginner course level as well. Close that. And if you were to notice, there is actually a small note here. It says these settings are saved in default engine.ini, which is currently writable. What do I mean by that is, if I head into my project directory and if I head into config, there are actually many config files. So for example, if I open up default engine.ini, it says edit a startup map equals, and it has the relative path of the map, and you have a bunch of other settings as you can see. These are useful. We will actually talk about config files in detail later on. There are other config files as well, most of which you won't use. You would mostly just use default engine.ini. Now heading back to our level, you see everything is completely empty. Now one of the first things that you will need is a sky actually. So if you just search in sky, you're going to find a skylight, sky atmosphere. We are just going to be using a skylight for now. And if you just type in atmosphere, you'd get the same sky atmosphere here. So you can go ahead and drag that as well. And if you type in fog, you'll be able to get exponential height fog. Now you will see the effects of it if you tinker around with this yourself. Basically all of these things just do what they say. So exponential height fog is going to add fog, and if you want to change the properties of this, always head into your details panel, and this is where you will adjust all the properties. Now for something like fog, the location and stuff doesn't matter. So anything you place, the location of it is going to be stored here, location, rotation and scale. Just know that location, rotation and scale combined in Unreal Engine is known as a transform. We'll be using that a lot. Now let's say you had a light which was fixed and you want the shadows to just be baked in and you have nothing to calculate dynamically. You could set your light to be static, or it goes the same with any other object. If you're not going to be moving it, it's going to be static. Stationary is almost like static, but there are a couple of things which dynamically changes. It's generally used for your directional lights, which acts as your sun basically. So we can drag that as well. So if I type in directional light, you see we get everything else that we need. If I remove the fog, you would see that the fog went. Now for example, here I have lost my directional light and or any other component. So in order to navigate to that, you can use this outliner window which will have a list of all the objects that are in your scene. You can do quite a few things actually. If you want, you could select these and you could actually put those in one folder. So I can go ahead and right click, create a folder, and I can just drag those inside this folder. You could do that as well in the outliner. So now let's say you lose your directional light, you can head over here and let's just call this one sky, for example. Let's just call it sky actors. I'll tell you guys why we call them actors a bit later on. So you can drag in a sky atmosphere, skylight and stuff like that. So these are the basic components of your sky. Now if I go ahead and zoom into my directional light, press E on my keyboard and rotate it, you see the sun moves along with it. So let's say we wanted an evening sky, we would use something like this. And if you would notice, the mobility is set to stationary. You could set it to movable, then everything will be calculated dynamically and you won't have to build the lighting. You could set it to stationary as well. You could set it to static if you don't have any moving objects in your level. Now let's go ahead and just save everything. Now let's start actually creating something in our level. So first of all, remember I told you about the landscape tab. This is what you would use if you have a larger world, but for our purposes, I'll just show you guys how to work with landscapes, even though we aren't really looking for a large world. So here you can select your landscape material, but you can change it anytime anyways. And let's say you wanted a water body or something, or let's say you wanted to have multiple layers, in your landscape. You can click on enable edit layers. And these things are basically a transform and stuff like that. And these things adjust these options, number of components and the overall resolution, adjust the size of your landscape. So you can play around with that. to see what the precision, or rather I should say the detail level of the landscape and the size should be. Depending on that, you can increase that, or you can go ahead and use a height map. I actually have a short on my channel on how to use height maps properly in Unreal Engine, but for our purposes we'll just create our own. So let's just create everything with the default options and let's hit on create. So it is going to take a while. And once we're done with that, we have a landscape. Now if I go ahead and press play, as you can see, I can navigate around this landscape just like you can navigate in any other level. So now what I'm going to do is I'm going to edit the landscape. Now these are the tools that we'll be using to edit our landscape. So you have to be under landscape mode, and under this section over here, you would find sculpt. You can increase the tool strength. You can get the brush type over here as well. One thing that you will use is probably the alpha brush. Basically you can have your own mask and stuff, but for our purposes we are going to be using the regular old circle brush. So I'll just increase the size. This need not be the limit actually. I can set this to 10,000 as well. So if I go ahead and do that, you see we have kind of a mountain here. Now what if I wanted to randomize the bumpiness in the map? I could use noise. So you see it's going to be like this, but this is overkill. So I can go ahead and change the tool strength to something like 0.05. And as you see, this is a lot more reasonable. So this is what noise does. Flatten, as the name suggests, is going to flatten your landscape at that level. So let's say select this level. Everything else is going to go to that level if I use flatten. Now obviously you can increase your tool strength if you wish. Completely up to you. And there are many other things such as the brush fall off. So basically if you want a softer brush, so you could use the brush fall off and increase that. If you want a completely hard brush, you could go ahead and use this, but as you can see it produces harsh effects, so we aren't going to be using that. Again, completely up to you. And erosion is basically if you wanted to create natural looking slopes and stuff. So for example, so I'll just reset some of these settings here. So something like this, you could experiment and find out what each one does. But generally you would stick to sculpt, smooth, flatten, ramp, and maybe sometimes you'd use erosion and you'd use noise. And let me show what ramp does real quick. So if I select ramp and if I go ahead and click somewhere and click in another place and click on add ramp, you see it bridges those two locations with a straight line, and this is going to be a ramp. You could add a ramp anywhere like this. So I can go ahead and do this and I can click enter, or I can press add ramp on the menu over there and it's going to add a ramp. Now if you had a character or something, you can walk over it. Now again we can use the smooth tool in order to smoothen this out. So now these two, this intersection looks seamless. So these are basically a landscape editing tools. There is not much depth to it, and not sure what erase does actually. So I've never used erase, to be honest. You would just undo changes if you really had to. And one more thing, if you wanted to do the inverse of an operation, so let's say I am sculpting a landscape. So let's say I wanted something like this. So I'll increase the tool strength. So make that, let's say 0.14. Now this is one way, but what if you wanted a pit instead of a hill? The way you do that is by holding shift. It's going to reverse the operation and it is going to make a pit. Same goes for the other tools as well. Shift is going to be the inverse of the operation. So that's about what you'll use in the Unreal editor most of the time. So now we can start creating our own assets. Make sure you first of all go into select mode again. Don't forget that. And now we can go ahead and start talking about blueprints. So let's start talking about Blueprint. Blueprint basically is the visual scripting language which is used to write game logic in Unreal Engine. So Blueprint code can be written in many types of assets. If you right click, go to Blueprint class, you can write Blueprint code in most of these assets. And we will get to some of the important ones a bit later. For example, actor, pawn, character, player controller, game mode. There are a few others such as the game state, player state, and so on. We'll be getting into all that. Now, the most basic type of blueprint is going to be a level blueprint. So if you head into this menu over here, click on open level blueprint, you'd see you'd get a blueprint associated with your level. Now, begin play is, as the name suggests, something which is called as soon as the game begins, or in this case, as soon as you open the level. Please do not interpret begin play as when you click on the play button. This is only called once you load into the level. So let's say you loaded into another level, the begin play for that level will be called as well. In order to actually start writing code, you would use some built-in functions or you could write your own. So the way you do it is if you right click for example, and if you just type in, I don't know, let's say set location. Now let's say you wanted to set the location of something in your level, let's actually do that. Since this is object oriented, you will need context for everything. So you need to know for which object you're actually moving. So for example, let's say we have a point light here. Now one handy thing which I forgot to mention before, let's say it's up over here and you want to snap it to the ground. You can hit end on your keyboard and it's going to go to the ground level. Now we have this. Have that selected and head back into your level blueprint. If you right click, you get an option, create a reference to point light. Now, internally, this is a pointer to this object, or rather, I should say to this actor. Anything that can be placed in a level is called an actor. Just remember that. Now, if I drag off of this, now I want to get its location, let's say, for example. Now, the search bar is really useful for that. You don't really need to know the function names, especially in blueprints. So just type in get location and you see get actor location. Now I can go ahead and print it, for example. So if I right click and type in print, you see print string. Now this is called a function. Even this will be called a function. So let's say I drag off of this and I type in set actor location. Again, every getter will usually have its own setter if it can be set. So what we are saying, what we are implying by this is set the location of this point light to be 0, which is what you've defined over here. Now let's say we just wanted to move it up a bit. So we can do plus, and on the Z we can do 200 because Z is the up axis in Unreal Engine, and we can set that to be the new location. So if I go ahead and press play, don't see much. See, mobility of the light is set to stationary, so we have to make it movable, of course. Remember what I was telling you guys earlier, with static and stationary you'd assume it to be in the same place, but with movable it's fully dynamic. So now if I press play, you see it became dimmer. In case you guys wanted to see the change, if you just press D on your keyboard and left click, you get a delay node, or you could right click and search for delay. But I prefer using D. If you press D and left click, you get a delay node. Let's just keep a delay of 2 seconds and then let's move it up. So if I press play, as you see, it got dimmer because it went up. Now, this blueprint function has a couple of pins on the left. So these are called pins, the stuff from which you can drag off of. Now, the triangular one or the pentagonal one, I don't know what shape this is, the one which drags off the white wires, these ones are called execution pins. So this function will be executed only when this pin goes from left to right. So only when you connect something to it from the left, and when this is executed, this is going to be called. And once this is done, this is going to be executed. Now this one is a function as well. Get actor location is a function too. However, it does not have an execution pin, you might notice. The reason is this is a pure function. You can define a pure function whenever you need a function to return immediate values. So what I mean by that? So for example, if I have this hit result and let's say I print this out. So I can't print out a hit result I figured, so let's just take location. Now this is just a sweep hit result, so let's say we move it somewhere and it collides with something in between, it's going to return a hit result if you have sweep enabled. Now if I print this out, this value right here is actually cached. So let's say I copy a print string and let's say I print this out again. Set actor location is not going to be called once again. This value what you had is going to be cached in your memory. However, over here, if I just drag off of get actor location and let's drag off of this once again. So let me drag this over here. This value is not cached. What I mean is get actor location is executed each time I'm calling this print string. Wherever I am referring to this value, the entire function is going to be called once again. And in this case it makes sense because whenever we execute get actor location, we want the live location of the actor, not the location which it was in previously. If we go by that logic, we would get the location before it was set. So we will get the live data using a pure function. And the target works in a similar way. We are getting the point light's location, so the target is point light. Now one more thing you might notice is event tick. Tick is basically a function which is called on every frame. So if I just hit print and if I just print out tick for example, you'd see it prints it a bunch of times. Basically every time a new frame is drawn, the tick function is called. Now whatever I told you guys is just a vague overview of how Blueprint works. So I just talked about execution pins and that it's object oriented and types are color coded. But now let's actually start talking about them one by one. So the first thing you'd want to do in any sort of a programming language or if you're writing any code is first of all be able to store data, and that's done through variables. Now the way you create a new variable in Blueprint is by clicking on this little plus icon on the left hand side. This menu is available in almost every Blueprint. So click on the plus icon and you can create a variable. Now let's just call it my variable for example. Now over here, since Blueprint is based on C++, obviously you have to define a type for it. So by default it's set to Boolean, but you can select any one of the other types. I'll go over some of the important ones. If you're familiar with C++, these things will seem pretty simple to you guys. So Boolean is basically a true or false value. So for example, if I drag my variable and let's say you want to get the value of a variable, you can drag it and hit get. So this is going to be the value. So off of this pin, let's say I type in if. We'll get to branching and stuff a bit later, but I can do stuff like this. Since this is a true or false value, if this variable is true, this execution pin is going to come out. If the value is false, this execution pin is going to come out. So that's basically how it works. Same way with all the other types. So I can click on this variable and change the type to integer, which is basically a non-fractional number. Int64 is basically a 64-bit integer. So let's say you have larger numbers, so you'd use integer 64. However, I don't really find many use cases for it. Float is a decimal number, and then you have name, string and text, all of which are string types. Most of the times you'd be using string. However, in some cases you'd use name as well, for example in tags, which we will talk about later. And text is mostly used for UI and stuff like that. So if whatever you see in menus and things like that, the strings over there are stored as text. So that's the data type you'll use. Now a vector is a struct with 3 floats in it, x, y and z. Now obviously if you don't know what a struct is, we will again talk about that, no issues. Rotator is a similar thing, except there is a limitation on what values you can have. You can only have a value of 0 up until 360. Beyond that, the rotator is going to be invalid. And transform is basically a struct again, which contains a vector, a rotator, and a vector. So location, rotation, and scale. So this is transform. These are the fundamental types which you use most of the time. However, if you go under struct, you would see there are a lot more. You will not use most of these. Some of the common ones that you will use are things such as hit result. So hit result is a common one that you will use. Now if I compile this and if I go ahead and drag this out, and if I go ahead and break, and one more thing, if you want to get this variable, there's a shortcut. If you hold control and drag it, you will get the value. And if you want to set this variable, you can alt drag it. So that's just a small tip I can give you guys. So now break hit result is going to show us all the different variables inside this. Now similarly, you can do that with any other struct. If you just drag off of this and type in break, you can do that. Or with some structs, you can even do split struct bin, or actually with all structs. So that's basically another way to see what members are there in the struct. So for example, similar to this was the same struct over here. So you see initial overlap, so this is going to be there, blocking hit, location, and things like that. So that's basically your struct. That's how it works in Blueprint. And one different type is going to be our object type variable. So for example, if I select an actor, and this was an object type as well, if I drag off of this, the variable which is color coded in your sky blue or your light blue color, so these are basically object references. Internally, when you write these in C++, so let's say you create an object reference for Blueprint in C++, you can expose C++ variables to Blueprint, by the way. They are stored as pointers. So basically it's the memory address to that object. Now if some of these things sound confusing to you, just stick along and watch the course till the end. And if you guys still have any confusions, make sure you guys do check out a video on pointers, and I will go over actors and stuff like that. Basically, this variable is going to refer to an actor, and since this is a pointer and the default value is none, so if I go ahead and click on this, you see it says none. So what this means is this is not a valid pointer, and if we actually had some logic in C++, it would throw an exception. So that's basically how object types work. And you also have enumerations, which are in some disguise just your byte, which is an unsigned 8-bit integer. So basically, for example, if I just grab a random enum over here, I can do a switch, which we'll talk about. So basically, depending on the value of this variable, you can perform your logic. So a common thing that you would use it for is, let's say you have a weapon in a game, and depending on the type, so let's say your weapon is fully automatic, you would have an enumeration. So one of these enumerators is going to be full auto, the other one is going to be semi-auto, the other one is going to be bolt action, and depending on that you would execute the appropriate logic. So that's one way of using enums. There are many applications, of course, we will get to most of them later. Now that's about how you basically create variables. So now let's actually talk about a few special types of variables, namely structs and enums. Now I did show you what's a struct and an enum, but I'm pretty sure it went all over your head if you're a beginner. So let's just delete that and click on this variable and hit delete to delete that as well. Compile and save that. Now go ahead and right click, create a new folder and call it structs. And I'm doing this in my content folder. You could do it in the same place if you want to follow along. Right click, go ahead into blueprints and create a structure. And for now, let's just call it my struct. Now, structs by definition in C++ is going to be similar to your classes. So basically you wrap a bunch of data and methods into a single unit. However, in Blueprint, a structure purely refers to a collection of variables. You cannot have functions for structs in Blueprint, sadly. However, you could just create a library for that. So you have Blueprint function libraries and you could just create functions for your structs. Anyways, so the way you work with this is you can create a bunch of member variables. A very simple example is going to be a 2D vector. Unreal Engine already has a 2D vector type, but just for demonstration purposes, let's just create one. So let's just call this x and make this of type float because it's a decimal number. Add in another variable, make it of type y, and make this of type float once again. So basically, my struct is going to contain these two variables. Now if I head back into my level, make sure you save this. And if I go ahead and right click somewhere and type in my struct, you see you get an option called break, make and set members. So if I go ahead and press break, you see you get options x and y. Now just like how you create an integer or any other variable, you can create a struct as well. So let's just call this one, I don't know, maybe my variable once again. And it's going to be of type my struct. So my struct is the type. So this is our user defined data type. Now I can go ahead and get this. I can right click, perform split struct bin once again. So this is basically how structs work. Basically you have one variable which stores multiple variables within it. So this can be very handy. For example, in this hit result, you have all these variables. Now they need not be the same type. The types can be heterogeneous. So I could have an integer over here. I could have a string over here. So let's say I have a student struct. I could store name, his roll number and stuff like that. So just a vague example over there. So that's basically how structs work in Blueprint. So I'll just delete that. We don't really need it, but we'll keep my struct. Let's actually have something more descriptive. Let's say we have name and let's say we have points. This makes no sense right now, but we can use this a bit later on. And you could anytime add a new variable, but remember, avoid removing variables from structs. Sometimes they do cause some issues with the Blueprint, so be careful with that. In C++ though, it won't be too much of a problem since you refer to the members by their names. So that's one thing to note. Now one more thing, if you guys want to set the members of a struct, what you do is you just type in set members and you can get the struct name, that is my struct in our case. So we can use this and set the members. Now over here on the right hand side under default category, you can get any one of the variables as pins and you can set the value. Now obviously you will need to tell it which struct. So let's say you created a variable of type my struct. So my struct, you can go ahead and pass that as the struct reference. Now this is a reference because this pin over here is diamond in shape or a rhombus or whatever that is. So that means it's a reference. So it is referring to the actual variable that you pass in. So it is going to adjust the value of this variable. We will deal with a lot of structs as we move on. However, there's one more special type which I would like to mention, and those are enumeration. So I will right click, create a new folder, and I'll call this one enums. Open it up, and over here I can head into blueprints again and type in enumeration. So this is basically a list of values and you could perform your logic depending on this list. So let's just create an enum and let's call this one my enum again. Now over here you can add enumerators which basically are list items. So let's say add 3 items. So for example, let's take names of fruits. So apple, banana let's say, and maybe a mango. Now once you do this, these are basically the enumerators which are there, and I will show you guys what it actually implies. So I'll just go ahead and create a new variable and I'll call this one I don't know, let's say fruits choice, for example, and it's going to be of type myEnum. Now internally, ultimately an enumeration is just a number. Basically it's a number between 0 and 256. So for example, over here, apple is going to be indexed to 1, banana is going to be mapped to 2, and mango is going to be mapped to, 1, and mango is going to be mapped to 2. So 0, 1, 2. So that's how it's going to be internally. Now obviously you can give a description as well over here in Blueprint. So if I just drag this in, now by default it is set to apple. You can see the default value on the right hand side, and we will talk about all these options a bit later on in the variable section. So just to be brief, if you are like creating new objects in your scene, you would need some of these, and for multiplayer and stuff you would need replication, and we will talk about them in depth, so nothing to worry about. Now you can cast it to a string. So Unreal has it built in to give this out as a string. So if you see, you should get apple printed. Oops, I have something on tick, so let's just delete that. So nothing's printing. Okay, we have a delay of 2 seconds. Let's just delete the set actor location stuff and just print this in. And we could actually change this as well. You can copy this and paste it by hitting Ctrl D. So if you click on this and hit Ctrl D, you can duplicate it. And if you drag off of this, you'll see you can perform a switch. So basically, if the value of fruits choice is apple, it's going to perform this logic. So let's just say healthy, for example. And for banana, let's just give something else. So it honestly doesn't matter. Copy that over, and let's say we give tasty for mango. So if I go ahead and press play, you should see it says apple and healthy. Now if I set this value, so if I alt drag it and I set this to banana, now you should be able to see that it prints the second string. So this is basically how enums work. And this was actually a bit of a lengthy way I did it. There's actually another shortcut you can use in Blueprint. In C++ though, this is the only way. You would just type in switch instead of using this node. So one more shortcut is if you drag off of this and type in select, depending on the value of this enum, you can make it do certain things. So let me remove the switch here. So now what I'm saying is if the value of fruits choice is apple, this is the value that will be passed. So in this case, I'll just type in 1 for example, and over here I'm going to type 2 and 3. So what we are saying is if the value of this enumeration is apple, it's going to print out 1. So the value which will be returned here is going to be this value. Same with the other two choices. So if I press play, you see it says apple and it says 2. That's because we had set our choice over here. If I change this to mango over here, we are going to get 3. So that's basically how enumerations work. Now that we have a basic understanding of data types in Unreal Engine, let's start talking about the core scripting features in Blueprint. So the first thing that you can do is create functions. Now a function is basically a block of code which adds functionality to your program. So what I mean by that? So in order to create a new function, you can go ahead and click on this plus icon right here. And we could call it whatever we want. We could call this one my function. And generally speaking, you would use Pascal case. So basically each word is going to start with an uppercase character. So generally that's a convention you use. You could use a space as well in Blueprint, but generally it's not a good practice. Now I can call this function from my event graph. Now if you see, you have opened two tabs. One is the event graph and one is my function. So I can close my function and I can double click on this on the left hand side to open it as well. Now if I drag this in, or if I right click and type in my function, you can go ahead and call it. So basically this is going to execute my function. So let's go ahead and actually do something with it. Now inside my function, this is blank right now. I can just go ahead and print a string, and we can call this one my function is executed. So I think I butchered the spelling, but doesn't matter. So if I go ahead and press play, you see my function is executed. Now we can also pass in values. So I have created this points variable here. So just create a new variable and make it of type integer and call it points. Now if you head into your function and click on this block right here, you can actually add input and output parameters. So if I click on the plus icon and change the type to integer, and I can call this one points. So I can take this points value from outside the function. So if you look at this now, you see I can pass in points. So that's pretty handy. Now I can go ahead and print this out as well. So I can print out my function is executed, and I can print out points as well. And if you double click on the wire, you can use the reroute node to keep things a bit clean. Now if I press play, you see you get my function is executed and you get 0. Now if I change the value of points, for example, you see we get that number. So this is basically how input parameters work. Now what if you had some return value? Now let's say instead of points this was health. So let me just call this one health. So compile that. And over here if I click on this once again, I can add in an output. And you see it creates a return node for us. So this is basically like your return keyword in C++. So when your function goes to this, it's going to exit the function, and the value whatever you want is going to be returned. Now you need not have it. You can have an empty return node as well. Now in our case, let's just return a boolean, and let's just call it be killed, for example. And let's change the name of this to be health as well. And we could do a simple if check. We will talk about if as soon as we finish functions, events and stuff like that. So if I can't do that, so let me just grab in an if. If this value, that is our health, is less than 0 or less than or equal to 0, then what we can do is, if it is true, and if you type in Control D, you can have two return nodes. So if our health is less than 0, it's going to be true, otherwise it's going to be a false. Now you can go ahead and print this out over here. Now our health is 32, so we should have false. Let's say we set our health to be -1, which is invalid of course, but we get true. So this is how you can return values outside a function. Now one aspect of functions which I did not cover, and I'm recording this a bit later, it is going to be local variables. So what if you had some variable which you wanted only within a function? So let's say for example we have a variable temp, for example. So let's say you wanted a number to be stored temporarily inside. So for that case you would use this local variable option. They work exactly the same as you would as it works in C++. And one more thing, the input parameters whatever you take are also local variables, so you can just grab an in, and instead of dragging this, actually you can right click and type in, and if I just get it, so I should find it at the very end or somewhere, or rather let me just type it, get in. So in is a really commonly used word, so that's the reason we are getting it so many times here. So let's actually change it. So let's just type in 1 2 3, let's say. So in 1 2 3, so you can get it actually. So you don't actually have to drag this. Let's say you have a large blueprint graph, you don't have to drag it actually. You could just do this over here. That works totally fine as well. Even over here actually, you could do this and it's totally valid. So that's about it for local variables. As you use them, you will kind of understand their purpose, but without a solid example, we will not actually be able to tell the use case. However, once we actually get to the end where we actually create something, that is when we'll get to practical examples. At the base level, those are what functions are, and we will go a lot more in depth about functions, events and stuff, so not to worry about that. I've just gone ahead and deleted that. Let's create a new one once again. And now let's talk about the limitations, and let's talk about the next type of scripting feature in Blueprint. Now, one limitation that you'd see is you cannot add a delay. So if I right click and type in delay, you actually don't get a delay node. The reason is you cannot have latent nodes inside a function in Blueprint. So delay is actually a latent function. So what I mean by that is it actually takes some time to execute. So let's say I cut or copy this and paste it in here. You see, I cannot do that. It says one or more copied nodes could not be pasted into this graph. So the way you can handle this is you can use a macro. Now macros in Blueprints are more like functions than C++ macros. So they work a little bit different. Now if I call this one my macro, for example, I can go ahead and add a delay. So I can hold down D on my keyboard and left click and I can add in a delay. One thing you'll notice is by default it doesn't have any input or output pins. You can go ahead and add that. But there is another advantage of macros. Now for example, let's say we have a database on our server, and let's say it takes some time to retrieve the data. So let's say it takes around 0.5 seconds for your computer to connect to the database and retrieve the data. This is just an example. It could be anything that takes time. For example, the prime number program takes some time to execute after you go to a larger number. So while this is being executed, now let's say you just wanted to print out something saying that it's starting, and then you want to do something else when it's completed. This is where it can come handy. Now you can type in print string and you can call this one starting now. You could come in here and now you'd notice this execution pin got disconnected. You can't do them parallelly, but there's a workaround for that. You can type in sequence, and over here you can just print this out and then you can go ahead and perform this. And over here in the output as well, you can drag this in, and a handy thing which you cannot do in your return node in your function is you can have one more of these. So now if I just give a longer delay so that we can recognize it, and if I drag in my macro, and if I print out strings over here and over here, so we'll call this one done, and here let's just print starting underscore outside, for example. So if I press play, starting now and starting outside got executed first, then after 2 seconds our done was executed. So things like that can be done by macros, which you cannot do in functions. Now the whole point of using our own macros and functions is of course code reusability. So let's say I want to call this macro once again. I can just type in my macro and I can call it. Now one difference I would like to mention, and then we'll head into the next one, which is collapse graphs, is with a function. Let's say I call this my function. I can actually execute this from another blueprint, but this is not true for level blueprints. It's a little more tricky to do it from level blueprints. You guys will understand why once we actually head into classes and stuff. But I'll just show you guys a simple example. So I'll just create a blueprint here of type actor, and we'll talk in depth about this later. And let's say I create a function. As you can see, the same features in the blueprint are available here, and let's just call it one test, for example. Compile that. Now if I were to get an object reference to new blueprint. So I'll just do that by dragging it into the level. So I'll drag this and I'll create a reference. And if you can notice, I can actually call test from here. However, if I create a macro, so let's just call this one test m for test macro, you would see, even once I save and compile everything, I cannot call test m. I see test, but I don't see test m. So that's one more difference between a macro and a function. You cannot call a macro from, other blueprints, but you can call functions from other blueprints. Of course, if you set the access specifier to be private in that, then you can't call functions either, but you can by default. Now, what if you didn't want to reuse them? What if you just had this code, but this looks a bit messy, so you wanted them to be shown as one node? Let's say this whole thing did something. One, you could just press C on your keyboard and comment it. However, there's another feature in Unreal called collapsed graphs. Now you can right click and click on collapsed nodes, and it's going to create a collapsed graph. Now you can have inputs and outputs here as well, but in my experience, I have never really bothered using them. And let's just call this one my collapsed graph. And if I go ahead and type in my collapsed graph by right clicking, so let's say I type in my collapsed graph, you see I cannot call it because this is not a function. This is just all of this code just stuffed into this collapsed graph. So I lost my event graph here. You can head back in, or you can click on this over here. So that's basically a collapsed graph. That's about it. And when we actually use them, you will get an idea. You can actually have further execution. So let's say I have this. So it's going to come out of here as well. So stuff like that. So I'll go ahead and delete that. It's not of much relevance. Now that we have studied about functions, macros, and collapse graphs, let's actually look at implementing the various programming constructs inside Blueprint. So we'll use the level blueprint again, and after this we will get to actually working with blueprint classes. Now, the first thing that you would want to do is do an if check, and we already did that several times. So if you right click and type in branch, or you could just type in if, or you could hold down B on your keyboard and left click. That's another shortcut which I like to use. You would bring up a branch node. So a branch node takes in a boolean, and depending on its value, it's either going to go true or false. This is an execution pin again. So depending on the value of this variable, you can go ahead and execute some logic. So instead of health, let's say I have be alive as a variable. So if the player is alive, for example, so put that in. So if the player is alive, then we are going to go ahead and run this logic. Otherwise, we are going to run this. Now, there's another thing which you can do with booleans, which I probably mentioned for enums, but you can actually do a select as well. So if I go ahead and select, you can go ahead and do this. So again, you can actually get this return value to change depending on the value of this variable. So this comes in pretty handy. Now this is the most basic type and there's nothing much to explain really. So you could go ahead and print something and maybe do something else. And if he's not alive, maybe you can go ahead and you can quit the game or anything like that. So that's basically it. Now, the next construct that you'll use is switch. Now switch is something which we already talked about, but we are going to go a bit more in depth now. Now I'll change this variable to an integer again, or rather I'll just undo everything so that we have our integer back. Okay, I've saved it in between, so we can't. So I'll just change the variable type. And for this, we are going to rename this to, let's say, health again. Now I have health. So, oops, let's just compile that again. Control drag it. Now if I drag off of this and type in switch, you would see that I get the switch on int node. Now basically what this means is if I just click on add pin, and you can also set the start index. So let's say you want it to be -1 to start with. You could do that as well, -2 for example. So what you're basically saying is if the value of health is 1, head into this execution pin. Otherwise, default is basically like an else. So if none of these correspond, so let's say we have 1, 2 and 3. If the health is neither 1 nor 2 nor 3, it's going to head into default. So for example, if I just go ahead and print, now since our health is 0 and we are starting at 1, we should get hello printed in theory. So we get hello. If I go ahead and drag off of 1, you're not going to get anything. Now the same thing, if I just change the value to 1, I change the health variable value to 1, now you should get hello. So this is how switch works. Generally you would be using this with enumeration. So for example, we have my enum over there. So let's just delete everything in the graph. Now my enum. Now if I grab this into the graph and if I then type in switch, you see you get the options. So if health, okay, we can rename that to something a little more descriptive. So let's just type in some enum. So if some enum is apple, this is going to be executed. If some enum is banana, this is going to be executed. If some enum is mango, this is going to be executed. So this is basically how switch works. So that's about it actually. Now, this was for your selection and to evaluate condition. Now coming to the iterative constructs, let's say you wanted to print numbers from 1 to 10. You can use a loop. Now if you guys are familiar with C, C++, these will seem much easier to deal with. There are basically two types of loop and there is a version of while loop called do while loop. So the types are while and for. And there is one more type which you use a lot, which is for each, and we will get to that once we start talking about arrays. Now if I right click and type in while, you see you get while loop. So what this basically means is as long as this boolean is true, so I can change this to boolean once again. As long as this is true, this loop body is going to be executed. So for example, let's actually make this a number again. Let's change this. Let's say we wanted to print numbers from 0 to 10. So I'd set the sum enum, or we'll call this one num. We can set num to be equal to 0 by default. And now we can do an if check. As long as number is less than or equal to 0, or rather 10, we can go ahead and print our number. So we can go ahead and type in print string, and we can just Control D, print it out. Now obviously this is an infinite loop. You have to change the value of num itself. So what I can do is I can set num to be equal to num plus 1. So this is one way to do it. Also, if you were to notice, if you just drag off of this and type in plus plus, you can actually do increment as well. So this is basically like your num plus plus in C++. That's how you would interpret that. Now if I go ahead and press play, you should see we get numbers from 0 to 10 as expected. So that's basically how you use a while loop. And once this loop is done, again you can go ahead and print something. So let's say printed numbers. Now you see it prints from 0 to 10 and it just goes to completed. This is how you'd execute your logic. One thing to note though, avoid using loops in your program, especially in Blueprint, unless the array length is, less than about a few hundred, it's fine. But let's say you're dealing with larger data sets, please refrain from using loops in Blueprint. try to use as much as you can in C++, because Blueprint, if I haven't mentioned yet, is slower compared to C++. When you call print string, for example, this is actually a function call in C++. So the actual function of print string is written in C++. It actually takes a little bit of processing to actually switch between Blueprint and C++. Blueprint is kind of like your JVM, where it actually runs on a virtual machine. So Blueprint code is going to be comparatively slower than C++. But in this case, this code is pretty simple, so you don't really need to do that. We will get to where to use Blueprint and C++ much later. There's nothing much to worry about for simple games. Now the other type is going to be a for loop. So if I just type in for loop, you see you get for loop. This is how you basically execute your for loop. However, this is a little more, or actually much more easier than what you have to do in C++. In C++, you give an initialization expression, an update expression, and a conditional expression. I mixed up the order, but anyways, you get the point. And you got to actually give the body of the loop like that. But here in Blueprint, you just type in a first and a last index, which makes it very simple for you to execute a for loop. And if you were to just drag this in, let's say I just type in 0 and 10, and I just go ahead and print this. We don't even need a variable at this point. We can just grab this and we can go ahead and run this, and it's going to print 0 to 10. So this is how you use a for loop. Now there is another variation known as the for each loop, which is used similar to range based for loop in C++ to iterate arrays and stuff like that. We will talk about that. Now again, the completed works the same way. Once this loop is completed executing, you can go ahead and print something or execute whatever logic you have. So this is your for loop. And there is another variant of for loop called the for loop with break. So if I just type in for loop with break, you see you get this. Now let's say I wanted to stop at a certain point. Let's say, in this case, it's kind of useless to do it. But let's say I wanted to stop in between. Let's say I have some logic. We can just grab in some random logic. Let's say this number divided by 15, we have to make this float, remember, because integer division works in a different way. So let's say this number divided by 15, if it is greater than 3.5, we want to break. Let's say we have that logic. So we are going to print as long as this number divided by 15 is greater than 3.5. So do that. If this is true, we are going to break. Whoops. And if we go ahead and print this, we can just go ahead and print the number instead. And once this is completed, we can print something else. Now obviously, to tidy this up, you can use a reroute node and you can do this. So this is one way to keep your blueprint graph tidy. So we can type in completed. So that's done. And we have a compiler error, it says. So okay, we'll take that in as a float. So convert this pin to a float, convert this pin to a float, and then let's just do that. And let's compile this again, save, and go ahead and press play. Now we would see it's 52. So if we actually bring up our calculator, so we get 51 by 15 is going to be 3.4, and 52 divided by 15 is going to be 3.466. So that should be the last number. So now if I do 53 divided by 15, you see you get 3.53, which is greater than 3.5, so it did not print that. Okay, now that we have talked about iterating, now it's a good time to head into our for each loop. Now for this, we'll need to learn about another data structure. Now this is a variable, right? Over here, where you select the variable type, to the right of it, you get an option to change it to an array, set, or a map. Now, an array is basically a collection of homogeneous elements. So basically, in this case, num is now no longer a single number. Instead, it is a collection of numbers. And why I say homogeneous is because I can only have integers in this list. I can't have 0 and I can't have a string in the next index. So basically, each item is going to be referenced by an index. So the first item which you put in is going to be 0, stuff like that. You can put in any number. And if I have to iterate through this, I will use a for each loop. Now, if I go ahead and print this out, you would be able to see that I print in all the elements in that array. So I printed in 2 and 32, which is exactly what we have. So that's basically how it works. Now, one more thing, you can have it of any type. In case you guys were confused, I'll create a new one. For example, let's just call it one str array, and let's make it of type string, and let's compile that. And I can go ahead and add a few elements. I can just type in any set of characters, and I could iterate through this as well. So I can just drag this in, compile that, and go ahead and run this program. Now you see, you can print that as well. So this basically stores multiple of the data types elements. And one more thing, since this is an array, this is more of a theory thing, but the elements here, so this string, so let's just actually name it 1, 2, and 3 for our reference. So 1, 2, and 3, these are actually stored in continuous memory locations. So iterating through them is actually a relatively cheap option. Now, unfortunately, Unreal Engine does not provide us with a linked list structures in Blueprint. We have to implement that ourselves if we needed to, but most of the times you'll be using arrays and maps. You'll not be using sets or linked lists most of the time. However, it is handy to use linked lists in some very rare occasions, but we will not be going over that anyways. So let's just delete all of this. We are done with this. So that's basically your array and your for each loop. Now you can have an array of structures as well. It's totally fine. So I guess we called ours mystruct, if I'm not wrong. We could have an array of those. That's about it. Basically, you could store any type of element. Now I can go ahead and click on the plus icon, and I can add the name and points, and it works just as you would expect. So I can go ahead and delete this. We don't need that anymore. Now, along with your regular if, switch, and your loops, Unreal in Blueprints provides us with a couple of handy nodes which you might need. One of them is called flip-flop. So what does it mean? So flip-flop is basically this is how a flip-flop works. If this execution pin goes in once, A is going to be executed. Otherwise, if you come here again, B is going to be executed. So let me actually show you what I mean. So if I just drag this in, and if I print, and let's just say A is executed, and now if I just go ahead and give in a delay of, let's say, a second, and if I copy this over and let's just type in B is executed, give a delay of a second, and again head back over there. So I'll just use a reroute to make things a little more clear for you guys. Now make sure you guys do comprehend this logic correctly. If I go ahead and press play, you would see it says A is executed, B is executed, and it's going to be alternating like that. So that's the use of a flip-flop. You could use this for key presses. So let's say you wanted something to happen when you press the key once, but you wanted something else to happen when you press the key again. So for example, let's say you have a scoping in thing in your game. So let's say you're scoping into your weapon. Let's say the first time when you flip-flop to A, you want the guy to scope in, and when you flip-flop to B, you want your weapon to scope out. So that's basically one place where you can use flip-flop. So it's pretty simple. Now, one more thing which the engine provides is do once. Now, do once, and there's also a gate node which you might need, but I've honestly never gotten an actual use case for this. So there's nothing much to really worry about this, but it can come in handy depending on your game, especially if you're going for, puzzle type games maybe. Not really sure. So do once, basically as the name suggests, it just allows you to execute this one time. So let's say I print this string and I go back to this. This is no longer an infinite loop. It's just going to execute it once. Look, it just executed hello, and that's about it. Now, let's say I want to call this function just once again. So what I can do is I can drag this into reset. So if anything goes into this reset, the function which goes after completed will be allowed to execute once again. So that's basically how do once works. I don't think there's any explanation required for it. So if I do it on tick, so basically every frame it's going to allow you to do it once again. And if I just go ahead and re-execute this, I know this is an infinite loop, but we do have a little bit of a duration for us in the tick. So that's how it will work. Okay, so it did stop the execution over there. That's a different thing. But yeah, basically reset is going to let you do that once again. So I can actually get a more practical example. So let's say we have a delay of 0.2 seconds and we do this. I can actually use a sequence. So sequence, remember the node which we used before. So after 0.2 seconds, I can go ahead and reset that. And after let's say 0.5 seconds, I can try executing that once again. So if I go ahead and press play, you see it works as expected. Whatever we spoke until now were just the basics in order to get you started with Unreal Engine. But in order to actually practically create a game, we need to first go into some background so that we can learn how to use classes and objects. Now, if you guys aren't aware, Unreal Engine or any game engine in general is going to be working on the principle of object-oriented programming. A bit of a background here. So there are two main programming methods that we'll talk about now. The first one is procedural programming. So this is the approach used in languages such as C, where basically your approach is mainly using functions. So procedures, that's what basically procedural programming stands for. So you have a main function and you have several other functions. Now this is the most simplest form of what it could be. However, you could have a function over here as well. So let's say you have function 4 for example, and maybe function 4 can call function 2 or vice versa. Doesn't really matter. But basically your whole program is divided into multiple functions and there is some global data on which it operates on. So you have some data over here and maybe function 3 accesses some data here. Stuff like that could happen in procedural programming. However, the approach which is used in Unreal in object-oriented programming languages such as C++ is going to be object-oriented programming, of course, as the name suggests. And here we use a principle known as classes, and an instance of this class is known as an object. So let me be a little more specific here. So all the data and functions, so for example, or in this case, this was a method, this was the main function, so we have one method here, another one, and we also have some data over here. So all of these is going to be encapsulated into a unit known as a class, and I will get to some examples later. So once we have this encapsulated, we can go ahead and create instances of these called objects. So basically your class acts as a template for these objects. Now the first question that pops up in your mind would be, why do we use object-oriented programming over procedural? Well, it's pretty simple to explain that. So if we look at the wrong approach, that is procedural programming, you would know that you would have a character, let's say for example. So let's actually talk about a character which you'll have in a game and how you would approach it with both programming methods. So in procedural programming, you would have a character. Of course, you're not defining any unit known as character, but let's say we have a character in a program and you're going to have several functions. So you have move, turn, jump. Of course, you'll have other functions. I just took the most bare bones example. And obviously, you'll have the character's transform. And if you guys forgot about what transform is basically location, rotation, and the scale combined. Then you're also going to have a velocity for the character, health, and other variables pertaining to your gameplay. However, there is one problem which you might notice. We do not have a unit which we can recognize as a character. So we have several functions. Let's say we call the move function, for example. Now, when we call the move function, we actually have no idea which character we are moving. So character itself is not actually an entity. So we don't have an actual entity known as a character. Our program just has functions. Same with the transform. We cannot instantiate another character. So this entire code isn't reusable. So that's the problem. Now, what if we head back into the object-oriented type? So if we head back, and if you can see here, we have a class and we have instantiated several objects. Now, if you were to actually model a character with this, you would have your character class. Obviously, with the above mentioned functions and data, I didn't want to rewrite that. So you'd have a character class. And now that we actually have a unit which we can identify as a character, we can go ahead and instantiate a character, and let's say we call it character 1. So we are going to instantiate it. And let's say we have another player, let's say an enemy. So we can go ahead and reuse that once again and instantiate character 2. So now we don't have to rewrite all the functions, and whenever we are actually writing code, we have an idea of which exact character we are referring to. So character 2 is actually a real-time entity, and this is known as an object. So character 1 is an object, character 2 and character 3, all these three are objects. Now if you were to remember, in our blueprint nodes, we had a target pin. So if I bring in, for example, set actor location, so I'll just use the same node, so set actor location. Now you would notice there is a character pin. Now if you were to just hover over it, it says actor object reference. Now in our programming approach, what this basically means is we have set actor location defined in our class. So let's say, for example, we have something like this. So we have our actor class. Now anything that can be placed in the level is called an actor. So let's actually create that. So actor. So inside actor, you actually have a set actor location method. So set actor location, I'll not write the whole thing. And let's say you instantiate actor 1. So let's call it A1, for example. When you instantiate actor 1, your program needs to know on which actor set actor location has to be called. So we have actor 1. So that is our target. So when we call set actor location, in our case, in our blueprint, we call set actor location. Now it needs to know on which actor it has to perform it. So when you call this, through the target pin, in blueprint, that's how you do it. In the target pin, you specify that, and the program knows that it has to set A1's location. So that's how it basically works. Alright, so it's time we apply whatever we learned just now. So head into your content folder and create a new folder, and we'll just call this one blueprints. And inside here we'll create all our blueprint classes and we will compare all of them. So basically the most bare bones one which you can create is an object. Now please do not confuse this with an actual object. We are creating a class and the class name is going to be object. We are basically deriving a class from this object class. This is how you basically start in blueprint. However, as you proceed further, you will understand. Note that this is not an actor, so I cannot drag this into a level. Now, as I'd mentioned before, Unreal Engine already has a 2D vector structure, but just to showcase what we can do with such classes, let me just actually create a 2D vector. So let's just call this one 2D vector, for example. Now please note, you cannot name a type with a number beginning in C++. However, you can do that in Blueprint. So let me just call this one vector2, for example. So if I open this up, you would see you have a standard Blueprint editor, you have an event graph, but you don't have your viewport and stuff like that, which you would see in an actor. Now one more thing you would notice is you don't have an event begin play. So you get an option to add a custom event, which is basically like defining a function, but it does not return anything, and you can call it just like a function. And we will be using a lot of custom events, so you would get an idea of what I mean. Now, in vector2, we are going to have two variables. The first two are going to be floats. So obviously we'll think about what we can have later on. So it's going to be an x and a y. So these are the variables which are encapsulated inside this vector2 class. Note that this is not an object, this is a class. And when we actually create an instance of this, we create a vector2. So that's how it basically works. Now, we don't want this x and y variable to be directly accessible. Now, the reason I want it this way is for data security. Now, I don't want to be directly able to write any random value to x and y. Let's say this was exposed and you could actually change this directly in memory. What would happen is, now for example, let's say I have a vector2 object. So let me just create that. So you use the construct object function. So construct object from class. So I think I misspelled that. So construct object from class. Yep, there we have it. So I'll just delete this. And if you go ahead, we will get access to our vector2. So vector2, for example. Now we have a vector2 object over here. So this is actually a vector2 object. We could go ahead and promote that to a variable. So it's going to create a variable of that type. And let's just call this one r vector. Now we don't want any other external entity to actually be able to directly set x. So this would be prone to lots of exploits basically. So that's the reason. What you generally do in object oriented is you make this private. You see the option over here called private. Now basically you will not be able to access x and y from here. So now if I type in get x, you see I can't get it. If I type in set x, I cannot set x. So that's one way of providing security to the data. Now what if you just wanted to access the value? That's pretty simple. You would just go ahead and create a function. So you type in get x value, for example. So get x and get y. And we are going to make this pure functions because we are just returning the immediate value. And we could add a compact node title and call this one x, and we'll call this one y. Now in the return node, we could just go ahead and return the value. So return node, and we can go ahead and grab our y here and return that. And over here as well, we can go ahead and return x. So grab in the return node and return x. So now if you wanted to access x or y, you can go ahead and type in get x. So you will get access to the x value. However, you will not be able to edit x directly. So again, for that, we can go ahead and create setters. So setters are basically just functions which are going to set the value. So let's say I type in set x and I type in set y. I accidentally typed x again. So set y. Alright, so once that's set, we can go ahead and take in the value. And this is going to be of type float. And we can go ahead and set our y to be equal to that. And we can go ahead and type in the return node. We don't really need it in this case, but anyways, we'll have it. And in our set x function, we could do the exact same thing. We could add in an input pin and call this one value once again. Value. And we can go ahead and add in a return node. Whoops, we didn't need that. Now what if you just wanted to set this entire vector? Now when we set our vector, we are actually just getting a reference to it. We are not actually setting our members. So we can go ahead and write a function for that again. We could add a get vector to, and we could also have a set vector to. So something like this. This was just to show you guys how you would work with classes and objects. So for get vector to, we can go ahead and actually return the value. So we can go ahead and add in the return node, and we can get our x and our y. So things like that. So for a set vector to, we can go ahead and alt drag this once again. Now obviously please do understand that this is kind of impractical. Unreal already has a struct built in which handles all this for us. I'm just trying to show you an example of how you would actually use it. So this is how you do it. So now if I type in set vector 2, you see I can actually set its value, and the target is our vector, so we are adjusting this value. And we could go ahead and write in a few more functions. So for example, we could write a function to print the vector 2. So print vector 2. So we can go ahead and type in print string, and we need a world context object. However, it is going to take the outer object by default, I believe. But anyways, in these contexts, what you would want to do with something which I haven't seen much is you would just get the outer object. There is a function for this. Basically, the outer object is the object from which this object was created. So in our case, it's our level blueprint, and we can call the print function from there. The reason is it actually needs to know where to actually print the string. So that's the reason actually. So now I can just type in self. Self refers to this object itself. So we can just pass that in. Now we can go ahead and actually print something. So in our case, we can get our x. And one handy function which you'll use a lot is going to be append. So we can go ahead and type in x for the x value, give a space, and then print out our x. Move that over there to keep things clean. And we can go ahead and do the same for the y as well. So we can go ahead and give a space, and we can type in y with a colon, and we can go ahead and print that. So we have our y. We can go ahead and convert that once again, and we can go ahead and print that. If you right click, you can actually remove the extra pin. So that's an option available as well. So now this is how you do it. Now if I go ahead and press play, obviously we are not calling it anywhere. So now that we have our vector, we can go ahead and call print vector 2. So this is going to print our vector. So this is how it works. And obviously we can also test out our set functions. So we can type in set vector 2, and we can just give some random values to this. And if we go ahead and print vector 2, we should get that value. So this is basically how you would work with the most basic type of object. Now this is mostly useful in cases where you only need some data and methods, and you want methods basically, because in Blueprint you cannot have struct methods. So in those cases you would use an object type. So we are not going to be messing with this any further. Now the next type which you will use is going to be an actor. Now this is probably the most commonly used type, and most of the other types of classes which you'll create will also be derived from actor. So let me just create that. Right click, go to blueprint class and create an actor. It's directly available here, or you could search down there. So if I create an actor, we'll call this one my actor, for example. Now if you were to notice, if I drag this, I cannot do that. because you cannot place a vector 2 in your scene, right? However, I can drag my actor and I can place it in the scene, and if I hit F on my keyboard, I can actually see it. Now this is just a visual representation in the editor so that you can actually see it. However, if you hit G on your keyboard to go to game view, it actually won't be seen. Now if you were to open your actor, you'd see the editor is a little more complicated than your basic object. You have 3 tabs: the viewport, the construction script, and the event graph, where you will be working with most of the time. We will separately talk about construction scripts and we'll also get to the viewport, but of our relevance is the event graph right now, and we will talk a little bit more about actors. You would also notice that we have our begin, play and tick, which we missed in our basic object type class. Now if we wanted to have multiple of these actors, so let's actually do something practical. Let's say we had a pickup actor in our game. So we have pickup actor, and it's generally a convention. You do something like this, BP underscore pickup, because more often than not, or here if you see the parent class, it says actor, right? So more often than not, you will actually create another class of your own in C++. So any code that needs to run fast or something, you would put that in C++, and then you would derive BP pickup from the C++ pickup actor. So that's why it's a convention. I usually name it like this. So I can go ahead and grab this. So I have BP pickup. Whoops, deleted the wrong thing. So I can delete my actor here. BP pickup 2 will be created. So these two are pickups, and both of these contain all the variables and functions which this creates. So we can go ahead and edit our blueprint just like how we would usually. Alright, so it's time to dive a little bit more deeper into some of these events, and let's actually start writing some practical code. So event begin play is called not when the game begins actually, that's the wrong way to interpret it. However, event begin play is called when this actor is instantiated. So for example, we have our BP pickup here, and since this is placed in our level, this will get created as soon as our level starts. So it is technically called when the game starts. However, if I just go ahead and print this, and let's just call this begin play, you would see 2 begin plays because we have 2 instances of our BP pickup. However, it need not be called when the game begins. It is called when the pickup actor is actually created. So when BP pickup is created, that is when it is called. So let's delete a vector 2 stuff. We don't really need it. Now in order to actually create an actor, remember that every actor is going to have a location, rotation and scale. So that's the reason you cannot just create an object, because you do need a certain number of default parameters in order to actually be able to place something in the scene. So without a location, the engine has no idea of where to place it. That's the reason actor exists. Now if you head back into your level blueprint, let's actually give a delay of a few seconds just to show you guys. So let's say we give a delay of 2 seconds, and in order to create an actor, you call a function known as spawn actor. So spawn actor from class, and over here under spawn transform, we could just set that to 0 for now. It's since we don't have any visual representation, it doesn't matter honestly. So once that's done, we can go ahead and select our BP pickup, and we can go ahead and compile it. Now if I press play, you see begin play is called, but 2 seconds later another begin play is called. If you guys couldn't catch that, I'll give a longer delay. Begin play, and another begin play was called. And if you would notice in the outliner, you would actually notice another instance being created here. So if you were to notice, there is another BP pickup that is created. So that's basically how it works. And tick is called every frame. However, it need not be once again. So if I just go ahead, or I can just go and reuse it actually. So instead of this, I'm going to type in tick, and now this should be called every frame. Let's only have one pickup actor, and let's go ahead and not spawn this. So if you want to disconnect pins like that, by the way, you can go ahead and press Alt over here, and it's going to disconnect the pin. So we don't need that. Now if you were to notice, it's going to constantly print tick. So this should be about 200 to 300 times a second on my computer. So if I just type in stat FPS, whoops, missed that, stat FPS, it's locked at 120, so it's 120 times a second. So if you want to increase it, actually you can remove the cap by typing in t.maxfps space max FPS. Give something like 999 or 1000. Alright, so I don't know why I did that. Now head back into your blueprints, under your pickup, and under your class defaults, you can actually disable your tick. So you can go ahead and disable, and as you can see, nothing's being printed. Now there's another thing. You can actually change this parameter at runtime as well. People don't know this, but any and all details which are there in this panel over here. So let's say, for example, I go to my class defaults. I will definitely be able to change most of these at runtime. So for example, we have start with tick enabled. So we should be able to enable or disable tick at runtime. So let's actually just type in tick enabled. And as you can see, there is actually a function which lets us do it. So if I go ahead and actually enable tick first of all, and if I go ahead and disable it after 1 second, you would notice that tick is being printed, and a second later it stops printing tick. So that's basically how it works. And not only that, any and all parameters, and you can actually change the tick interval as well. Let's say it's printing too often, you could just set it to 0.5. So it will be roughly 0.5 seconds. Now as you can see, it is not printing as frequently. So that's basically one aspect in blueprints that is handy to know, because any and all settings that will be there will be usually exposed as functions to be adjusted at runtime. Otherwise, again, you have your class defaults where you can actually set them. I think whatever we did till now is clear now, so we can go ahead and delete this code. We won't be using it as of now. So now let's go ahead and actually write some code for the pickup itself. So let's say we had an object and we had to pick it up. First things first, there is no visual representation for the object. So let's say we actually just go ahead and, whoops, we go ahead and press play. You would see that you can't actually see anything. Now, if I zoom into this, so as you can see, you can't actually see this pickup. So first of all, let's actually add in a model and stuff like that. Now, there is one thing. The default scene root is not actually required. If I delete it, I won't be able to. However, I can actually add in a static mesh. Now, a skeletal mesh is a mesh which contains bones and stuff like that. So basically, your characters and anything with animations is going to be a skeletal mesh basically. However, your models like your pickups and stuff usually are going to be static meshes. So that's basically how it works. As you use them, you will understand. So now if I drag this into the default scene root, I'll go ahead and delete the visual representation and the static mesh will be replaced. Now one thing to note, when you do this, the most high component, the component which is the uppermost in the hierarchy over here is called the root component. So for example, this default scene root is the root component now. When I drag the static mesh, this is the root component. And if physics has to be simulated, in our case, let's actually try that. Let's make the pickup fall down and follow the laws of physics. So in that case, we will need it to be the root component. So that's one thing to note. Now, if I go ahead and select a mesh, so for example, I can just select this random sphere that we have. I think it's way too big. So yeah, we got to adjust that. Now I can go ahead and enable simulate physics. So now if I go ahead and press play, you see that it falls like you would expect. So we basically simulated physics. Now we have a visual representation. Now how are we actually going to pick this up? Now actually let's select something a little more smaller because I don't think this is convenient. Okay, this seems like a reasonable size. So if we go ahead and press play, we are simulating physics, so absolutely no problem with that. And one thing to remember, in case you are not simulating physics, make sure you do have collision and stuff like that. If we actually encounter such an issue, I will go ahead and show you guys how to deal with that. So we have physics now. Now we can go ahead and set up some logic now. We want to be able to pick this up when we overlap it, let's say for example. So we can do on actor begin overlap. So what this says is when another actor overlaps this actor, so in our case it's going to be this, when it overlaps this actor, we can go ahead and perform some logic, and Unreal Engine has set this up for us. Now there is one problem though. This is just our cube, which is our model. However, we don't have an actual bound, so our code won't really be able to know when to actually call on actor begin overlap. So even if I disable collision, so the way you do that is you can head over here, and from physics actor you could go ahead and change it, but we do need physics, so we can't do that. Even if we actually bump into this, you won't really notice anything happen. So if I go ahead and bump into this, nothing is really going to happen. Now if I actually go ahead and create a bound, so the way you do that is right click, or rather go to add, and you can type in sphere, I believe, sphere collision, yes. So when you create a sphere collision, we could call this one bounds. You would have created a sphere, and you can't see that because the size is too small. You can go ahead and increase the sphere radius. Now these are our bounds. So as soon as we enter this, our on actor begin overlap will be triggered. So we can go ahead and print it. And if you were to notice the collision preset over here under the details panel, select this and head into your collision preset. You see it says overlap all dynamic. And obviously if you select custom, you can go ahead and edit each channel, and we will talk about this later. So if I go ahead and press play, you see we get hello every time we overlap it. Now hello is going to be printed every time any other actor overlaps this. However, we want to print hello only if a character overlaps it. And it need not be a character as well. Now in Unreal, character is actually a derived class of another class known as pawn, and I will talk a little more in depth about this right now. So basically this is how it's laid out in Unreal. Basically we are looking for a pawn, and I will get to that in just about a minute. So we can type in pawn, and if you were to scroll down, you would see cast to pawn. So cast is another programming feature. Now if you were to feed in an object to this, you can check whether it is a pawn object. So now if I go ahead and print this out now, you would go ahead and actually get hello just normally. The reason is, when you are actually controlling your camera over here, you are actually controlling a pawn actor. Anything that can be possessed by a player controller is known as a pawn, and we will talk a little more in depth right now. And just to clear your doubts on whether this logic actually worked, let's say it wasn't a pawn, so which means it's not a player basically. So if I copy this over, and instead of hello, let's just print not player. And now if I go ahead and press play, you'd see you won't get anything. And if I overlap it, it says hello. But if I go ahead and copy this over, and let's say keep it above this, and if I press play, you see you get not player printed. That is because the box overlapped another box, or rather our BP pickup overlapped another BP pickup. However, those are not characters. So this cast right here failed because the object which came from this actor begin overlap was not a pawn. Hence, we got not player printed. Now, since we are still at the beginner part of the course, I'll just tell you guys the most basic form of inheritance hierarchy which is there in Unreal. However, once we get to the more advanced part, I will tell you guys more in depth. But as far as what you guys need to know, So at the base level, the most simplest type of class from which you can instantiate objects is known as object in Blueprint. So object is the simplest type, and from that, the most basic one which you can create is going to be an actor. Now an actor is basically an object which has a transform and can be placed in the level, as you would have figured by now. Now under this you have various other classes. However, for the most basic level, we are going to be considering only two. So there are many more, and we will talk about many others where once we actually come to the advanced part, but these are the two which you do require to get up and running. So the first one under this is going to be your controller. So a controller, as the name suggests, is a class which has functionality for you built in to take player input and stuff like that. And under controller, you also have a special type known as a player controller, and there are others such as AI controller. So you have a player controller. So player, and I'm just going to put this. So player controller. Now a player controller is basically a controller which belongs to an actual player. You also have other things such as AI controllers, which is assigned to CPU players basically. So if you have enemies in game for an offline game or something, you would assign an AI controller. Now another class that you'll need is pawn, and that's what we talked about. So this is called pawn. Now a pawn is basically a class which is an actor obviously and can be placed in the level. And note that you cannot place a controller in a level, although it is derived from actor, it is actually an exception. Controllers, player states, game states, there are a few other classes which are exceptions and you can't place them in the level. However, pawns can be placed in the level, and a pawn is always possessed by a player controller. So a player controller is going to be possessing a pawn. So when you call the possess function and you give the target as a pawn, you are going to be possessing the pawn. And one special type of pawn which has a lot of functionality built in for us already is called a character. Most of the times you will be working with characters and not pawns. However, you can use pawns. So by character I mean a character such as a living being basically. So generally if you have like a human or if you have like an animal or something like that, you would generally use characters. However, if you have something like a vehicle, you would usually stay away from characters because it has some properties which are not realistic for those. However, it is completely possible to use a character class for something like a vehicle as well. So you can possess a character as well. There is no harm in that. Pawn or any derived class of pawn can be possessed by a player controller. Since we have the basics in order to get us started, we can go ahead and actually create our own character class, or I should rather say pawn class, which is also a character class in our case. So we can create that as well as a player controller, and I'll show you guys how to set those and how we can go about interacting with this pickup using those. So right click, go ahead and create blueprint class, and as you would see, you have character and player controller right here because they are really common. So type in character and let's just type in BP underscore character. Again, you can name it appropriately or as per your wish. Now if I go ahead and open it up, you see this looks a little more different and it already has something set up for us. And some of these are quite handy, especially the character movement component which is there. And if I haven't mentioned yet, whatever we did here under the components tab, these are called components basically. Basically every actor is made up of several components, and you can actually create your own components as well and make them behave as you wish. But as of now, just know that these are just constituents of this actor, and these are the constituents of BP pickup, and these are the constituents of BP character basically. Now we haven't set a mesh and we don't really have one, so let's just take, okay, we have a character, tutorial TPP, and one thing to note, this arrow actually represents the forward direction of the character, so you can go ahead and move it down and you can go ahead and rotate it 90 degrees. So let me have snapping enabled. So rotate it by -90, and you can go ahead and bring him all the way down until I feel it's correct. Now we don't have any animations, but I'm not really sure if we do have an animation blueprint for him. So let's just check tutorial animation blueprint, I guess. Tutorial TPP animation blueprint. So yeah, we do have an animation blueprint for him. Now, if you want to change the default character that you'll be using, the way you'll do that is by first of all heading into Window, World Settings, make sure that is enabled, and then over here on the right hand side, head into World Settings, and under Game Mode Override, you can go ahead and set your own game mode. Now, if I were to just select game mode, I still cannot edit it. So I will get to game mode classes later on because they're not that important, but for now you can just go ahead and create a new game mode, and it could be of type game mode base or it could be of type game mode. It doesn't really matter, but I would suggest sticking with game mode base. And let's just call this one BP underscore game mode. I just did something there. So yeah, BP underscore game mode. That's what we'll call it. And now under this, we will get our option to select the game mode. Now, since this is our custom made game mode, we get the option to select the default pawn class. And over here, we can select our BP character. And if I save everything, and if I go ahead and press play, you'd see that we have indeed possessed our character. And you were to notice that the camera is a bit off. So what you can do is you can actually create a camera. If I go ahead and type in camera under the component section, you can create a camera and you can align it as per your requirement. So this should be about correct. So I feel rotating this a bit, maybe a bit back, maybe a bit to the side would be nice. So there you have it. So this is our character. However, we are not actually able to move. The reason is we haven't actually written the code for it to take our input. Now, setting up input in Unreal is really easy, and I will show you guys the brute force method as well as the proper way to do it. So the brute force method is, for example, we want W to be able to make us move forward. So you can press W, and if you just give a space and type in keyboard, you would be able to get W, and we can make the character move forward. So in order to make your character move, basically there's a function for us built in already under the character movement, and not character movement, I believe it's there in our pawn class, I believe, or a character class. So if you right click and type in add movement input, so it's written in our pawn class, we can go ahead and make him move. And if you were to notice, we have to provide a direction and a scale value. Scale value is useful if you're on a joystick or something where you can partially press down. So let's say you're halfway pushing the joystick knob. So in that case, it would be 0.5. So the scale value can be given through an axis value. Now, if you were to notice, there is another problem here. When I actually plug this in, it's not really going to work as you would expect. So for our direction, we need the forward direction of the character. So a very simple way to do that is typing in get forward vector. So get actor forward vector. So get actor forward vector. So that's the way you would actually get the world direction. That's how you would do it. And if you were to notice, it's not going to work as expected at all. The reason is this has to be called every frame in order to actually work. So the way you do it is type in, or rather we can do it on event tick, for example. So if we go ahead and do it on event tick, I'm just doing this to show you guys how to do it. If I do this, now we would see that our character is moving forward. Now the most obvious question is, how am I actually going to set this up? So there is something known as an axis mapping which runs every frame. Basically what add movement input does is it moves you a very slight amount, and by calling this multiple times in a single second, you are going to be adding considerable amount of movement. Now if I head into my project settings and under input, this is the right way to do it. The brute force way would have been like doing this on tick, and I'll just show you. This really shouldn't be your option, but I'll just show you just in case. So for example, we could just have a boolean here and we could just set this to true, for example, and when you release it we could set this to false. Now this is wrong, so don't really worry about the logic. This is just gonna work, but you shouldn't really do this. So we could do if new variable is true, we want to move, otherwise we don't want to do anything. So if I go ahead and press play, I can press W and move, but as soon as I release it, I'm going to stop. This is the brute force way to do it, but Unreal has a much more elegant system to do it. So we can go ahead and delete all of this. Head into our project settings once again. And under input, you would see action and axis mappings. Now we want an axis mapping because we do want to be able to control the scale. And since add movement input is actually a function which depends on the scale value. So remember what I told you about the joystick. So we can create an axis mapping. So for things such as jump, where there is no scale value, so it's either jumping or not jumping. So wherever you have a toggle, you'd have an action mapping. Wherever you have some value which goes linearly, you'd have an axis mapping. So we can call this one move forward and make that Pascal case, and we could have W on the keyboard for that. And again, for move backward, we could reuse this actually. So S is going to be move backward, and for the scale value, you can make this -1. Now, if I right click over here and if I type in move forward, you would notice that we have an axis mapping. So if I grab this into this input event, or rather if I bring this into this axis move forward event, and for the scale value, if I put this under axis value, now this will work exactly as I would want it to. So if I go ahead and press W, it's going to work, and even S is going to work now for us. So this is basically how you do axis mappings. Similarly, you could do it for move right. So we could have move right, or we could call it move sideways. And we'd have our A and D keys. So we have our A key and we have our D key. So D is going to be this one and it's going to be -1. So let's actually just test it out. So it's not really doing anything because we didn't set up the logic obviously. So move sideways, whoops, axis move sideways. So once you have the event set up, you can go ahead and add the movement input, and again you can get the right vector of the actor. So basically the right direction of the actor is going to be your right vector. So your forward vector is always in this arrow's direction and your right vector is going to be a vector in this direction basically. So right vector, and if I go ahead and press play, so it's always 1, so that's the reason it's happening. So if I plug that into the axis value, I am moving reverse actually right now. So that's just a simple mistake I did here. So I can type in -1 for this and I can type in +1 for this. Now everything should work as expected. So if any of your directions are reversed, just multiply the axis value by -1. Now as you can see, we are able to move forward, left, right, and all of that good stuff. Now that is about it for the keyboard input. However, if you were to notice, I really can't rotate the character. So let's actually set that up first. So first things first, head back into your BP character, and the functions which we require to set up keyboard input, mouse input for our character is going to be your controller pitch input and your controller yaw input. So controller pitch input and controller yaw input. So these are the functions that we need. Now again, since our mouse needs to be captured as much as possible because it has to detect every tiny movement, so we again need to create an axis mapping. So go ahead into inputs and create 2 new axis mappings and call one look around, and the next one call it look up. And for this, look around is going to be the x-axis of the mouse, so type in mouse x, and for this one type in mouse y. So that should be good. And over here, if I go back and if I type in axis look around, and we can go ahead and add yaw input over here, and over here axis look up. Oops, I misspelled that. So head back into input, so look up. Now if I go ahead and compile this and press play, you would see that I am able to look around. However, I really am not able to, look up and down. That's mostly because your character isn't really meant to rotate along with it. So that's the reason it's happening. So if I head into my camera and enable use pawn control rotation, and if I press play, you see I am able to rotate my camera. However, there's one small problem here. We are again doing it reverse. So again, in that case, as I told you guys before, just change the scale value to -1. Now if I go ahead and press play, you would be able to see that our camera is working as expected. Now there is one slight issue though, that is our view is kinda off, which you can fix. But when we actually look up, our character doesn't seem to be looking up. But the reason that's not happening is because you can't just rotate the whole character. Now if I were to actually go to this main tab over here under BP character, and if I search for control rotation, so if I type in control rotation and if I enable it to use pitch, you would actually see that I am in fact able to do that, but there is a small problem. Now if I hit F8 to unpossess my character, you see he just rotates like that. However, we want only his spine to rotate, and that is something which we have to set up using an animation blueprint, which we will do later. So for now, we'll just disable this. And even for the yaw part, you could disable this, and you could technically do something like this and maybe set up some other logic in order to actually rotate your character, but for our purposes, we'll only do it for the pitch. Another tiny thing that I would love to cover here is how do you actually set up different sensitivities? Because obviously right now, the current sensitivity may be a little too much for some maybe it's a little too less. So the way you do that is you just multiply this axis value by your sensitivity value. That's basically how you do it. So multiply this and multiply this as well. Press Ctrl D to duplicate that. Now we could just promote this to a variable. However, remember that this BP character refers to only the character which we are playing. So let's say we are playing a death match or something where your character dies and you respawn with a new character. You would have to pass in the variable every time. So instead of doing this, we are going to set this up in a class which will be common even when your character is destroyed. So the class which we'll use, and as you would expect, is called player controller. So go ahead and create BP player controller. So make sure everything is in Pascal case. Now if you open this up, now over here we can go ahead and create a variable and call this one sensitivity. And now this is going to be of type float obviously. And let's make this one private. And let's create a method to get the sensitivity. Now this player controller is going to be persistent even after your character dies. So that's the reason we are using it. And since we need the immediate value, this will be pure. And for the return value, we are just going to return the sensitivity. Now obviously, the reason we are doing it this way is you don't want an external entity to actually modify sensitivity, that would be crazy. And one more thing, make sure you set this value to anything other than 0, because if it's 0, your mouse obviously will not move. So maybe something like 0.5. So once that's done, I should be able to set my player controller first of all. Over here in your game mode override, for your BP game mode, go ahead and change your player controller to the one you created. Save that and open up your BP character. And now on begin play, what we can do is we can actually get our player controller. So we can type in get player controller and we can cast this to our, as you would guess, BP player controller. So we are getting our player controller and we are checking if it is a BP player controller. Obviously we set it over there in the game mode, so it will be. There's no way it's going to head into cast failed. So we can just right click and make this a pure cast. So this just helps us save some space in the graph. This will be a success for sure. And we can go ahead and type in promote to variable and we'll call this one PC ref for player controller ref. Now go ahead and compile that. Again, you can go ahead and make this one private, but honestly it doesn't matter in this case. So on begin play, we have gone ahead and stored our player controller. And from our player controller object, we can go ahead and get the sensitivity. Go ahead and get the sensitivity. Go ahead and do the same thing over here. Compile that. And if I go ahead and press play, you would see our sensitivity works. And not only that, actually, if I go ahead and change the value, so let's say I make this 0.01 or rather 0.05 for example. 0.01 would have been too less. Now as you can see, I can make very precise movements. So now this sensitivity option definitely works. So this is how you would actually go about setting up sensitivity. Obviously if you really didn't care, you could just have a variable here and stuff like that. Doesn't really matter honestly. And there's another thing which you could do is first on begin play itself, you could go ahead and pass your sensitivity over here and you could promote this to a variable over here. And instead of calling the function every time, and make this one private once again, instead of calling the function every time, you can go ahead and use the sensitivity variable. So that's a little more better in terms of performance. This is something which you could do as well. Now remember, we are only able to do this because the player controller is always created before your character spawns. Let's say your player controller is not yet created by the engine, you can't actually do this. So let's say I go to my player controller and I'm not sure if I can do it on begin play. Maybe it would work on begin play, but technically if I type in get player character and if I type in cast to my BP character and if I go ahead and print a string, copy that over and I'll just type failed for this. And doesn't matter to be honest, and I'll type in success. Now if I go ahead and press play, you see we get success. However, this happens only because our player controller is probably created, or rather the begin play is actually called after the character is created as well. However, now I'll just show you guys another class. Now we'll discuss more in depth about this, but if I just type in game instance, I can go ahead and create a game instance class, and this is actually referring to your whole game application. So if I type in event init, this is when your game starts. It's not like the begin play where you're actually, talking about when this entity is created. The event init is actually called when the game starts. So that's one difference. So over here, if I go ahead and put this logic over here, and if I go ahead and go to my project settings and change the game instance to new blueprint, we'll delete that soon. And if I go ahead and press play, you see it says failed because our character is not yet created. So that's one thing to note. The begin play logic only worked because our character was already created. Now let's say we added a 2-second delay. Now this is gonna work. So now if I do this, it's gonna work because our character is now successfully created. So that's basically one thing that you guys need to understand. Just make sure all your entities are valid before you actually set them, and we can go ahead and revert our game instance. So again, we'll talk about all of this more in depth. This is not something which you would really worry about at a beginner level. Now save everything, and that should be good to go. To go a little more in depth on the part where you'd actually check if this object is created. So in our case, I mean, everything just worked out smoothly, but what if it didn't? What if this wasn't valid yet? Because as I told you guys, the default value is none. What if this wasn't valid? Well, there is a fix for that as well. There is actually a function called isValid. So if I go ahead and type in isValid, there's actually a macro which is created for us. So what we can do is we can go ahead and actually do this. So if we can convert this to a normal impure cast. So on begin play, we can go ahead and do this. We can check if it is valid, and if it is not valid, we would not want to do anything. But I mean, if it is valid, we want to set the reference obviously. But if it is not valid, we want to again check after a while. And if it is valid, obviously after setting the reference, you would want to go ahead and set the sensitivity and do the regular stuff. Now what if it's not valid? Now how do we actually check once again? So for this, you would use a technique known as polling. So polling is where you repeatedly call a certain function until a certain condition is met and you actually get your desired result. So the way you can do this is by using a timer, and that takes us to the next important concept. Now if I right click and type in set timer, you'd see you'd get a few nodes over here. However, the only one which you'll use is set timer by function name. Set timer by event is kinda pointless in my opinion, because even if you do use this, you can actually refer to an event by the function name itself. So most of the times you would be using set timer by function name. So use set timer by function name. Now it returns us a timer handle which allows us to control this timer. And what this basically means is it is going to call the function with a given name. So we can right click on this and type in collapse to function, and let's call this one, for example, get references, or let's call this one initialize. And we don't really need this in the event graph. And over here we can copy over this name. So what we are basically saying is after certain time, call this function once again. So we can have a very small time such as 0.01 seconds and make this one looping, because if you just set this to 0.01 without the looping, it's just going to execute it once. And we can go ahead and store the handle of the timer. So we can call this one initialization timer. And once we have that, this timer is now set, and we could just comment it out and call this one polling for references. Again, you could name it a little more descriptively. You could give it a color as well. That's one cool feature in Unreal. Honestly, you would never use it, but yeah, I just showed it. And under initialize, we need to stop the timer once we actually finish everything. So once we finish setting the sensitivity, there's no reason for this function to run again. So we can go ahead and get our timer handle first of all. And if you just type in clear, you'd get an option called clear and invalidate timer by handle. Go ahead and call that. This is how you stop the timer. Copy this, and if it is not valid, we don't really want to do anything, and if the cast failed, again we don't really want to do anything. So again, yeah, this cast is bound to fail actually. This check is kind of useless in this case. So we can just go ahead and do this, because if we don't have a play controller, this cast will obviously fail. But anyways, I'll just keep it like this. And now if I go ahead and run this, what will actually happen is every 0.01 seconds, it is going to repeatedly call the function until we have cleared it. So once we get all the references, we go ahead and clear the function. clear the timer. There are some key differences though between doing this and using a delay. Obviously you could have done this as well. So you could have done delay, and let's say we gave 0.01 once again, and over here we can go ahead and call initialize, and we can go ahead and loop this. Obviously we can call this first. So initialize, then after 0.01 seconds we could do this, and maybe we could check if we have all the references. We could maybe return a boolean over here or something and do something like that. The difference between a delay and a timer is that a timer is going to be very precise. It is going to be precise usually up to micro or even nanoseconds if you have a precise timer. This one I believe is precise up to a couple hundred microseconds. So as far as my testing is concerned, you could use chrono in C++ and actually test it. So this is going to be accurate. However, a delay is going to be very inaccurate. So that's one thing to note. If you want something to time accurately, you would use a timer. Or in our case, we needed the looping functionality, so that's the reason we used the timer. Since we have built a fundamental idea on how inputs work, now we can go ahead and check the other type of input, that is input action mapping. Now before that, let's actually just clean this up a little bit. So just comment it out and type in movement, and maybe you could type in movement and camera maybe. So movement and camera. So now we can just group these. Now head back into your project settings, and under input again, if you look at action mappings, you can go ahead and add one, and we can call this one interact, and we could set that to the F key. Now the advantage of using it through the project settings like this rather than brute forcing, so you could do F over here as well. So if I just type in F and give a space and type in keyboard, I can actually do this, but this is not the proper way to do it, because these action mappings can be actually changed through your in-game settings menus. So you can actually create a menu inside the game and allow the user to change, or allow the player to change these key bindings. So we'll call this one interact now. So action event interact, and this gives us a pretty basic pressed and released option. So when we actually press it, so we want to be able to pick up an actor. Now how are we going to actually set this up? So first things first, remember we had our actor begin overlap. Instead of doing it here, it's always advisable we do it from the character. So do your actor begin overlap here, actor begin overlap. Once you call the actor begin overlap, over here for the other actor, instead of casting to a character, since we are the character ourselves here, because we are inside the character class right now, we can cast to the pickup instead. Now that we have casted to BP pickup, we are checking if this is actually a pickup. Now there is a better way to do it using interfaces, but that is a much higher level concept than casting, but I will definitely get to that a little later in this course. So we'll probably change this to use an interface. Even that is casting at the very fundamental level, but that's a more elegant solution to do things. Now if this is actually a pickup, we can go ahead and actually store it. So promote to variable, and let's just say let's just call this one nearby pickup, and what we can do is on our actor end overlap, so end overlap, over here we can go ahead and again cast it, first things first. And if it is, we can check if it is equal to the nearby pickup. And if it is equal to the nearby pickup and we have left its bounds, we can go ahead and remove it and invalidate the reference. So we can alt drag it and we can set it to be equal to none. That is going to invalidate a reference. So that's about it. Now, once we have our reference, what we can do is we can head in our interact function, check if this is valid. One more way you can do it is by right clicking and converting this to a validated get. So if our pickup is valid, which means we are near a pickup, so what we can do is we can actually call a function. For now, let's just print out a string, let's say. So, or rather we can just destroy it. So type in destroy and you will get destroy actor. If I go ahead and press play, and if I go close to it and if I hit interact, you see I destroy the pickup. And if I do that once again, that is not gonna work. The reason is, once our pickup is destroyed, it's no longer valid. So what we have to do basically is check once again if we have any pickups nearby. So that's actually really easy to do. So once we destroy it, we know that our nearby pickup isn't actually valid. So we can go ahead and set our nearby pickup to the nearest one. Now how do you check that? Again, using a function. So we want to see if we are overlapping. So type in overlapping. And you already see you actually get options for get overlapping actors, which is exactly what we need. And for the class filter, it's obviously going to be BP pickup. And over here, we get an array of actor references. Instead of getting all of them, we can just get the first one. This is an array, so obviously we have to get the first index of the array. So once we get that, we can go ahead and cast this to BP pickup once again. And it is going to be successful all the time, so we can just make this a pure cast, because we are actually using the class filter here. And then we can go ahead and set the nearby pickup. So now our logic should work for both the pickups. So if I hit F, one of the pickups got destroyed. So I shouldn't have moved back actually. So if I press F, one got destroyed. If I press F again, the other one got destroyed as well. And there are no errors. So this is basically how you do something like a pickup. Now obviously, before you destroy it, let's say you had some properties. Let's say for example, let's say this was a health portion or something which gave your player a couple of health points. So we can add in, I don't know, let's say health points. Obviously you'll have a better inheritance hierarchy and we will get into that. So health points, make this a float. Let's say we have 10. So what we can do is, for now we can just go ahead and print it. So we can grab this health points and we can just print it out. So move all of this logic a bit over there to make space. We can just print that before destroying it. Make sure you call print before destroy, otherwise you're going to get a log error. Now if I go nearby, if I press F, we are going to get 10 printed every time. So that's basically how you do it. However, let's say you wanted to change some of these properties depending on which pickup it is. Now, apart from having these as a variable, you can go ahead and check these two options called instance editable and expose on spawn. What these will do is allow us to edit these properties when we actually spawn it. So let's say we spawn a pickup, for example. So over here, let's say I do spawn actor. Let's say we spawn a pickup. You see, we actually get an option to change our health points. So we could do something like 90, for example. And for the spawn transform, we can just get a random location, let's say. Let me just add in something for us to recognize. So something which you'd use for such a case is called a target point. So you can use a target point. So this will represent a point in space. You can copy this over and we can go ahead and paste it in. Or okay, maybe we can't do that here. You can do it in the details panel. So 1150 and negative whatever this value is and 650. So 650. And we have health points set to 90 over there. Now as you would see, we actually spawned another pickup. Now if I go ahead and pick these up, you get 10. But when I go near this, I get 90. However, it need not be restricted to spawning it through the blueprint. You can actually edit expose on spawn variables right here as well. So even when you're placing them in the level, you could have this to be 20, for example. So if I go nearby, you'd see 10, 20, and this one is obviously going to be 90. So stuff like that, which you can do using expose on spawn. You can expose any variable on spawn and they will be passed right into the actor, and the value which you pass in would be set to that variable. And now we can go ahead and remove this logic. That was just for showcasing purposes. And we can go ahead and collapse this to a function and call this one, call this one pickup. And along with this, maybe we could also have something like door open or something. Let's say this is not valid. We could go ahead and perform door open or something like that. We could go to the return node and we could have a sequence node here. So first we would check for a pickup, and we could also do something like a door open or maybe anything else probably. Maybe if you had some sort of an interaction system with the player or something, so you could interact with the other player. Stuff like that, which you can do using these input bindings and using the overlap events. To showcase that, let's actually do one more of the interaction events. Now I will show you guys how to do it the better way with interfaces later, but this is the brute force way. And if you have maybe 1, 2 or maybe 3 or not more than 4 interactions, you could use this method itself, the one which we did with casting. So this is totally okay for small things. Now let's actually do it. So right click, create a new actor, and let's call this one interaction actor. Maybe we could just nudge it or something. So let's say we have another static mesh, make that the root component, and we need some sort of bounds, so sphere collision maybe. And for the mesh, let's just take a cone for example. And also I've gone ahead and deleted the code which we had inside BP pickup since we are not using it. And over here, go ahead and simulate physics. Make sure you don't forget that. And we can go ahead and, okay, maybe we can have a smaller one for example. So I'm not really sure. I'm just looking for any mesh that's available to us because we haven't imported ours. Okay, this is way too big. Okay, this sphere seems like a reasonable size. We can go ahead and increase our bounds. That's about it. And once again, over here we can head into our BP character, and what we can do is we can copy over the same logic. So instead of nearby pickup, we are going to have something else. So if this cast fails, so if whatever we are nearby is not a pickup, we can check if this is actually an interaction actor. So we can do cast to interaction actor, and again, other actor is what we are checking. If it is the interaction actor, we can go ahead and promote this to a variable and call this one interaction actor. Again, I prefer going with Pascal case. Alright, now when we actually go away from it, we can again do the same cast. So we can copy this over, we can paste it, and for this actor, if it is equal to the interaction actor which we were nearby, so copy this over, grab in the interaction actor. If it was in fact the interaction actor, then we can go ahead and invalidate it and set that to be equal to none. So that should be about it. Now over here in the interaction logic, we can go ahead and check if this is valid. Right click, convert to validated get. So if we are near an interaction actor, what we can do is we can, instead of destroying, let's actually add impulse. So add impulse. So add impulse. So we want to add impulse to the root component here, which is simulating physics. Basically, these are the physics functions. You have impulse, force, torque, and all sorts of stuff. Obviously, you could spend some time and study those, but we'll not get into that. So we have a sphere here. So static mesh is the root component. So we need to get the static mesh. If I go ahead and scroll all the way down, I should see get static mesh. Now this variable refers to the component. Even components are objects, so you can just get them as variables. And for the impulse, what we can do is we can go ahead and get the forward direction of a character, get forward vector. Now you could change it according to your, this is logic based, so it's nothing much really. And we can multiply this by a certain value. So we can make this one a float and change this to a float. Make this, let's say something like 10,000, something big maybe. Get actor forward vector, multiply that by 10,000, and that should be good to go. Now we can collapse this to a function, and we can call this one nudge ball or something, because the sphere looks like a ball, so nudge ball maybe. And if I go ahead and press play, okay, we have a compilation error, so we can check what's that. So it says, let's read the error first of all. Okay, it was just, it just compiled it in the wrong order. It compiled character before this, so it didn't know what static mesh was. Now we should be able to go ahead and play this. And first of all, we don't have an interaction actor. Let's actually create one. Go ahead and press play. Now if I go ahead and bump into this, oops, I shouldn't have bumped into that. If I press F on my keyboard when I'm overlapping it, the bounce is a little too small. Let me just increase that. So increase the radius, don't scale it up. And one more thing, if you want to see the bounce just for testing purposes, you can set this flag called hidden in game to false. So now it is going to be visible in the game as well. So if I look around, yeah, there we have it. So we can enter our bounds. And now if I press F on the keyboard, you see we actually nudge it. So the force is way too small. So I can go ahead and make this something like 50,000, let's say. So if I go ahead and press F over here, you see we are actually nudging it. So this is the way you would set up interaction using casting. Obviously you can use interfaces to simplify things a little bit. But yeah, this is the basic idea. Alright, so in order to understand whatever I just told now, in case it went above your head, please do tinker around and try some of the functions yourself using the context sensitive and the search bar basically. So when you right click and let's say you drag something off of this, you can go ahead and type any random function. So for example, if I just press A, you get a bunch of functions. Maybe you could have a look at all of these. Maybe have a look at documentation and maybe try out some of your own logic and try out something else. Maybe add in another actor to do something else with, maybe add in a door and make it open or something. So you guys should be able to try it out yourself. And once you are actually done with that, now we can go ahead and talk about the next part. Now, until now, we talked about the basics, and I'm pretty sure you can write some basic game logic with whatever we have done already. But there are a couple of functions which the engine provides us, which is going to make our job a lot easier. The first one, and one of the most commonly used ones which I would like to talk about, is raycasting. Now, if you guys are familiar with other engines, you guys would know what a raycast is. But in Unreal Engine, you call it a line trace. So if I right click and call line trace, so you see you get a bunch of options. The one you'll use most of the time is line trace by channel. Multi is basically used when you have penetration and stuff, when you are detecting multiple hits in the same line. I'll tell you guys what's line trace first. So line trace is basically a function which lets us draw a line from a given starting point to a given ending point, and in between these 2 points, if you are actually hitting anything, you are going to get it as a hit result. So I can get access to the hit location. And in case you want to see the line itself, you can change this draw debug type enum and make this for duration. And if you guys wondered, this is an enumeration. That's the reason we are getting these options. So none, for 1 frame, for duration, and persistent are the enumerators. So if we select for duration, we are going to get the line for some time. Persistent means the line is going to be shown to us forever until you close the game, of course. So let's actually do something with this. So let's actually set up an input event. Let's say when we click our left mouse button, so we can type in left mouse. Now I'm just setting this up brute force because I don't really know what exactly we are going to set up. Once we actually get to the examples, we'll do that. Now for the start location, you can choose the camera's location of the player because this is where you would be seeing stuff. So you can select the camera's location, for example. So if I go ahead and get the start location, the way you do that is there are a couple of ways. You could do this and you could do get location. So you can get world location and you could use this as a starting point. And the way you would go forward towards the center of your screen is going to be first of all by getting the forward vector. So you can get the forward vector of this camera and multiply this by a certain value, again by a float. We'll do that. Add that to the starting location. So starting location plus forward vector into a certain number that is going to be your end, and we can go ahead and change this to a float, and we can do, let's say, 50,000. I mean, the number is arbitrary. Obviously Unreal uses centimeters, remember that. So anything that you type in will be in centimeters. So 50,000 centimeters is going to be divided by 100, so it's going to be like 500 meters. Now if I go ahead and press play, if I press my left mouse button, you see you get a line drawn over there. So if I press F8, you see I can actually see the line which was drawn. So the red thing which you see, that is the line which was drawn. And as you can see, where it hit the surface, it actually registered a hit. And in order to show that, there is one more thing which you can do actually. Oh, and about the other options, trace channel is something we'll talk about later. But basically you can do stuff like ignoring several types of objects. So let's say you had a shooter game and let's say you wanted to like ignore teammates, you could use it for that. But you'd use tags for that as well. But there are several other use cases. Camera is another thing. Depending on what type of objects you want the hit to detect, you would do that. And actually if you were to notice, if I select my mesh, and if I scroll down to the collision part, so I'll just type in collision instead of searching for it like this. So collision, you were to notice it says character mesh for the preset. And over here, if you see, there is actually visibility and camera. So what you can do is you can actually make it block certain things. So now let's say I wanted this line trace, which is using visibility right now, to block it. I would have to change this to custom and make this one block visibility. So then I would be able to make this line block it. Stuff like that which you could do. Now obviously I'll change it back to character mesh. We didn't do anything, but still. So over here, change it back to character mesh. And let's say you wanted to ignore the camera channel, you could do that as well. Now let's say you wanted to just mark the place where you actually hit. So now we have access to the hit location. So there is a function called draw debug sphere. You can actually draw many other shapes, but sphere is the one which you'll use most often. And the center is obviously the place where you hit it. So out hit location and radius 100. Maybe we can have 10 seconds for the duration, and thickness, let's just say 2 units. Line color, let's set that to maybe something like a greenish yellow or something. Now if I go ahead and press play, if I left click, you see it's drawing a sphere where it actually hit it. And you could change some of the properties. Let's say you wanted a more detailed sphere. I don't know why you would want that though. And maybe reduce the radius of the sphere. You could do that as well. So as you can see, we are registering a hit over there. So that's what it's basically showing us. So this is how you do a line trace. Basically you draw a line from one end to the other and you can detect hits. Obviously for shooting a weapon and stuff like that you use it. Now there is another way you can actually determine the start and end location. Now whatever logic you have here is fine if you only have one camera. But what if you had a first person view and a third person view, for example? Let's say you had two cameras. You cannot check which camera you're using and stuff. That would make the logic complex.